any relationship. The better you know your dual band router, the better you can connect to your Wi-Fi. A dual band router lets you switch between two frequencies, whether you want speed
Dalam
or rate.
ini ya, kan?
Gaming or
Meeting kat
streaming,
dalam.
5 GHz will give you faster speed but within a shorter distance. But when you're further away from your router, switch to 2.4 GHz for wider coverage but slower speed. That's how you can enjoy drama-free connections anytime. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi. Hey, you okay?
I was trying to find a strong Wi-Fi signal.
Well, look at all these things. They affect your Wi-Fi, you know.
What things?
The microwave oven, items with reflective or metallic surfaces, all these can cause interference. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
Assalamualaikum. Now we are waiting for honorable guest for ceremony opening at 8:45. So please be patient and stay tuned.
Hey, you okay?
I was trying to find a strong Wi-Fi signal.
Well, look at all these things. They affect your Wi-Fi, you know.
What things?
The microwave oven, items with reflective or metallic surfaces, all of these can cause interference. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
While waiting for our honorable guest, you can click the registration link. It's now available in the chat box.
Hey, you okay?
I was trying to find a strong Wi-Fi signal.
Well, look at all these things. They affect your Wi-Fi, you know.
What things?
The microwave oven, items with reflective or metallic surfaces, all these can cause interference. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to our honorable guest, Professor IR Dr. Hairul Azhar bin Abdul Rashid, Professor Dr. Xu Yu, Dr. Sumaisan, Professor Dr. Tariq Abdul Rahman, Dr. Kiratpal Singh, Professor IR Dr. Hafizal bin Muhammad, Associate Professor Dr. Madini bin Rosli, Professor Mahmud, Associate Professor IR Dr. Muhammad Huzaimi, presenter and participants, ladies and gentlemen. Welcome to the 2020 IEEE International Symposium on Telecommunication Technologies ISTT 2020. I am Azni Linda from UITM, will be your host today. To seek the blessings from the Almighty, I would like to invite Muhammad Izwan to lead the Dua recitation.
Assalamualaikum warahmatullahi wabarakatuh and good morning. Bismillahirrahmanirrahim. Ya Allah, Ya Rahim, praise be to God, the Lord of the worlds. Peace and blessings upon our Prophet Muhammad sallallahu alaihi wasallam and his companions and for those who followed his example till the judgment day. Allahumma ya Allah, on this blessed morning, in conjunction with the 2020 IEEE International Symposium on Telecommunication Technologies, ISTT 2020, we request, bestow and grateful towards you in favor of all the infinite blessings to us, your humble servants, to live in safe and prosperous life. We seek your blessings for a flawless progress of this event from the beginning till the end. We seek your guidance to steer clear of events that would detrimental the progress of this event. Ya Latif Ya Rahman, please bless us with your taufiq and hidayat. Please guide IEEE Communications Society to greatness, peace, glory, and prosperity in this world and the hereafter. Make us a responsible intellectual, granted us with a valuable knowledge that will be beneficial to mankind in order to gain your mardatilah. Make us your righteous servant that followed your commands and neglect the sinful act. Please forgive us for our wrongdoing. Ya Munzil al-Barakat, bestow peace to our beloved country, Malaysia. Preserve us from any threat and disaster. And to you, Ya Allah, we ask for security and prosperity upon us, our leaders, and our country. Bestow patience in us in order to face the challenges from you. Please accept our deeds and please reward us accordingly. ربنا عليك توكلنا وإليك أنبنا وإليك المصير. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم والحمد لله رب العالمين. آمين.
Amin, Amin Ya Rabbal Alameen. Thank you, Muhammad Izwan, for the Dua recitation just now. Ladies and gentlemen, for your information, the International Symposium on Telecommunication Technologies ISTT 2020 is an international conference aimed at exchanging current and latest information in the field of telecommunication engineering. This event is organized by the IEEE Malaysia ComSoc and VTS Joint Chapter. The conference creates a forum for engineers, scientists, and practitioners of varied disciplines and their associated applications. Throughout this event, we hope to create an opportunity for researchers, academics, and students to get together and, more importantly, to welcome new peers in diverse areas of expertise. This 3 days virtual conference offers an index publication by the Web of Science, WOS, and Scopus. Aligned with the conference theme of emerging technologies in IoT and 5G, we strongly believe that academic institution and industrial growth can be achieved through the implementation of effective programs, cross-functional collaboration, and the building of networking that allows for a greater capacity through knowledge sharing. This year, we have international delegates from Germany, China, Turkey, New Zealand, Jordan, Philippines, and India. Welcome to all. Our symposium is sponsored by Telecom Malaysia and Favorite Sindrian Berhad. Without further delay, I would like to invite Professor IR Dr. Hairul Azhar bin Abdul Rashid, Vice President, Research and Innovation, Multimedia University Malaysia, MMU, to deliver the opening ceremony speech.
Thank you, Puan. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everyone. Bismillahirrahmanirrahim. Yang berbahagia Associate Professor Engineer Dr. Madini bin Rosli, the General Chair for IEEE ISTT 2020. Yang berbahagia Associate Professor Engineer Technologist Dr. Juliana Johari, the Dean, Faculty of Electrical Engineering, University Technology Mara. Yang berbahagia berbahagia Profesor Dr. Mahmud bin Ismail, General Co-Chair of IEEE ISTT 2020. Yang berbahagia Associate Professor Engineer Dr. Muhammad Huzaimi bin Yusof, the Conference Chair for IEEE ISTT 2020, distinguished keynote speakers and participants of the conference. I'd like to take this opportunity to welcome all of you to the 2020 IEEE International Symposium on Telecommunication Technologies, ISTT 2020. Ladies and gentlemen, I think it's a very great morning to have ISTT and to present to all of you and thanking you for joining ISTT 2020. Now, on behalf of MMU, we are proud to co-organize the conference today virtually together with University Technology Mara, UITM, and the IEEE Communication Society and Vehicular Technology Society. This is the first conference in the history of our university and IEEE in Malaysia, which is completely conducted on digital platforms due to the COVID-19 pandemic. It's a great pleasure to introduce to all of you the esteemed guests in this 3-day conference who have come from all over, and the conference has been organized biannually and a couple of times in collaboration with other major conferences. And it's also my pleasure to welcome all the participants today to the 3-day conference. I'd like to take this opportunity to also welcome the eminent speakers, participants, guests from all over the country, from various universities and research institutions who have convened here today virtually. Although I must say that I missed the face-to-face experience, physical experience, who have come here to share the knowledge and vast experience with all the participants of ISTT 2020. And also this will be a good platform to see interaction between various research communities, universities, research institutions, industry especially, for the benefit of the many. Now, ladies and gentlemen, this year's ISTT conference theme is Emerging Technologies in IoT and 5G. Alone and in combination, I believe that the emerging technologies in IoT and 5G will usher a decade of change, new technologies, new applications, that will make the last 10 years look pretty lame. And so the main outcome of this conference is to arrive to national and international framework for the research and collaboration of the future, especially in the areas of IoT and 5G. And just like every year, the theme of the conference changes, and we'd like to cover every aspect of our society through this 3-day conference. This conference is a unique theme which is relevant to what's happening throughout the world in 2020 vis-a-vis COVID-19. I would like to thank all the invited speakers, the presenters, authors, co-authors for your commitment and contribution to the conference. Yeah. And my deepest appreciation is to the keynote speakers, Professor Dr. Shui Yu from
privacy requirement. In reality, obviously, your privacy is different from the others' privacy requirement. For example, my privacy requirement is totally different from a movie star, right? So the third is AI privacy. This is a very hot topic currently in data mining. So I give you an example about location privacy and personalized privacy. For example, I'm in University of Technology, UTS, in Sydney. I want to release this information. I'm in UTS, right? But the audience on the internet, there's a lot of people, they may interested about my location, but someone are very close to me, someone is not that close, someone are totally strangers. So depends on the closeness degree for the audience. I may add different level of noise to give them different answers. For example, my very close friends, I let them know I'm in Sydney, at UTS. Some friends, they are maybe not that close. I add a lot of noise to my location, then they only know I'm in Sydney. Some people, they are not close to me, then I add more noise, right? So they may only know I'm in Australia. So that's an example for location privacy and personalized privacy. We did some work in this. As I presented in our previous work, we focus on measure the social distance between the publisher and the information retriever. We measure their social distance, closeness, right? So we measure the distance between Alice and Bob, Bob and Chris. So there is a different ways to measure this distance. The simple ways to see in the social network, do we interact with each other? If we say interact 100 times, then our closeness is 100. If we interact with each other only 50 times, so our relation closeness is 50 or something like that. But this kind of measure is not accurate. For example, Joe Biden and Donald Trump, they interact a lot on the social network, but doesn't mean they are good friends, right? Sometimes they are opponents. This kind of simple measure doesn't work. So anyway, the core is to measure the distance of pairs. But we find that there's a lot of work to do in terms of personalized privacy. We just started. The second part of this talk, I want to share with you the current fundamental challenges of privacy research. I think there's a lot of challenges, but some of them are in the top of the list in my mind. Number one is measurement of privacy. Number two, modeling of big data. Number three, tools for privacy study. I will give details in the following slides. When we want to study privacy, we have to measure it, right? What's your privacy requirement? What her privacy requirement? So the current privacy environment, we usually use information theory tools. For example, you can K-alarmity, information leakage, entropy variation, social distance. Those are all based on information theory or statistics. However, we found that all measurements are not direct measure. They are either indirect or relative. So no direct privacy measure so far. Because if you give a person, give a profile, you ask what's the privacy requirement, we cannot answer, right? We can only say this guy, movie star's privacy requirements is higher than a general citizen, for example. So you see this guy, Isaac Newton, 400 years ago, he said, I can calculate the movement of stars, but cannot measure the madness of man. That means happiness, madness, privacy, this kind of soft concept is hard to measure. 400 years ago, I believe it's also hard today. Then you may ask, what's the possible way to explore the privacy environment? I believe the direction is cross-disciplinary study. So when we talk about privacy, I believe it's not the main business for computer scientists, not the main business for communication scientists. I think mainly they are the business for psychology domain, social science scientists, right? So if we want to tackle the privacy environment, we have to combine the knowledge from psychology, from science, social science, from law, right? So that's a cross-disciplinary study. It looks beautiful, however, there are big gap between this cross-disciplinary domain. We tried, but so far not too good result. The second challenge is big data modeling. When we say we do research on big data privacy, so we have to understand big data. So you have to ideally have a mathematical model to represent big data, to represent big data properties. On top of this, then we can do the big data privacy study, right? In terms of big data modeling, there are some nice work, some tools. For example, someone use graph theory. That's a geometry method. Then a big data set becomes a big graph. Then you work on the big graph. But if you use graph theory, we have new problems. You know, graph theory, it was invented a few hundred years ago to study the static graph, right? But now the internet, social networks, those kind of networks, they are dynamic. So my point is the graphic theory, this tool is not suitable for our studied subject. So now some people are working on the time varying networks. Okay? You can see the researchers from top universities, from, for example, MIT or Berkeley. I noticed that some of them are working on dynamic features of graph theory. Well, graph theory is a geometry method. We also have matrix. This is from the algebra domain, right? We can calculate. So the tool is tensor. It's used a lot by, say, for example, Albert Einstein, this kind of scientists, they research on the space. So that's called a tensor. If you're interested, please find some textbook about differential geometry, right? Or the classic textbooks for physics students, okay, called tensor. Well, we can also use statistics. So statistics are very powerful for our domain, for communication, right? But when we study statistics, when I was in college, our lecturer said small probability is impossible. So we do not study small probability, rare event. But now with big data, we do need to study the small probability or rare event. Okay, the tool is large deviation. It's a tool from probability theory. Okay. If you're interested, please refer to the related books. I have one free one for you on the internet. So this book, you can search on the internet called Large Deviations for Performance Analysis, Cues, Communications, and Computing. This is say for communication and computing students. Right? The third challenge I believe we have is lack of mathematical tools. Now, in terms of privacy study, differential privacy is almost the only new tool for us. So we do need tools for privacy. Maybe we can collaborate with scientists, with the mathematicians, but based on my experience, it's hard to talk with mathematicians, and they also think it's hard to understand computer scientists. So I think a feasible way is to transform ourselves to mathematicians, to semi-mathematicians. We understand their tools, then come back to solve our problems. Now we talk about AI for privacy. Well, now it's very hot, right? Maybe the hottest topic in ICT domain. However, we noticed there's two papers recently. There is a lot of negative voice about AI. For example, in 2018, in this article published in Science, say, has artificial intelligence become alchemy? They question the quality of AI. The same author, 2 years later, it's called Matthew Hudson. He published another article in Science called here, Core Progress in AI has stalled in some fields. Right? So in conclusion, the progress of AI in the recent 20 years is quite limited. So now the situation itself, you see, some colleagues are working on explainable machine learning. So they are trying to explain why the conclusion is like this. Right? So AI itself is hard to explain to us today. So sometimes they do learning, they get some conclusion. Sometimes they don't know the why. They cannot explain it solidly. So the AI, in my mind, just like six blind men and the elephant. Sometimes it's like a wall, sometimes like a string. So because the essential problem is no theories yet or no inappropriate tools. So AI itself is still in an early stage. If you cannot explain it clearly, solidly, so how can you do the AI privacy? Right? Well, that's point. Give us an impression. Give us a conclusion that we are at the early stage of AI. We are at the early stage of AI privacy. I show you the evidence in communication domain. So this is a small study I did in October 7th last year. You see in our top venue, actually ACM-TUN. So they have, at that time, they have total 30 papers in early access, only 2 using AI related. So TO's transaction on communications, 8 out of 162. Transactions on wireless communication, 6 out of 125. So you see, around only 5% of the papers are AI related. If you look at the top journal for AI, it's called PAMI. So there is, at that time, they only have 1 or 2 papers about privacy or security. Well, you may ask, what are we doing now using AI for privacy? So currently, based on my understanding, based on my reading, people are applying differential privacy to neural networks. So neural networks, you have learning in one and one, right? Sometimes they add a noise decided by differential privacy at the last round of learning algorithms, or every round of learning algorithms try to protect the privacy. Now, a hot topic is federated learning framework. In the previous learning, they gather the data in a central place and then do the learning. So with the GDPR, the privacy regulation, so you cannot move the data from Australia to Kuala Lumpur, or from different cities to the capital city, right, to do learning. So you have to keep the data in your local place. In order to do learning, then people proposed a federated learning framework. So you keep your data in your local place, but we have a central server. The central server has a learning model and a parameter distributed to the different members, and then you do the deep learning at your local place. You upload the parameters back to the server, and the server do some aggregation and then broadcast the update of the parameters to the members. Then you learning again. So you goes round and round. Finally, hopefully, we can get some conclusion in terms of learning. So that's the federated learning framework. Now it's very popular for privacy. However, the federated learning framework also face some problems. One is poison attack, because when we do federated learning, we may involve, say, thousands of or even say hundreds, thousands of participants. For example, you learning the mobile, you ask mobile users to learn their behavior. So you may involve, say, thousands, maybe 100,000 of mobile users. So you don't know who are the bad guys. The bad guys may inject wrong data on purpose to mess up your learning, right? So that's called a poison attack. Well, the second attack, now popular problem for is say, when you do the federated learning, sometimes the server is curious, right? The server may observe Alice's updates, and then the server may use a AI method called GAN, generative adversary network, may use GAN to recover the data of Alice. So that's called data recovery attacks. And all the traditional attacks can be applied to federated learning. For example, distributed denial of service, phishing, and so on. Right? So at this moment, what has a promising direction, I believe, is based on the theoretical solution space and the AI solution space. If both theoretical solution are at the overlap space, I think that's the solution may be reliable. We do need tools. So now the most powerful tool is cryptography tools. So if you look at the history of cryptography, they have symmetric encryption, then they have asymmetric encryption, and then they have ABE, called attribute-based encryption, right? So symmetric encryption serves two people, so the sender and the receiver. If you have the key, you can decrypt my message. Asymmetric improved make the communication more easily, right? ABE, so one message can be shared, one secret can be shared by a number of people, maybe a dozen of people. Right? So that's ABE. But now, in terms of big data publishing, we want to share the data with anyone, right? With a lot of people. If I have say COVID-19 news, or COVID-19 medical data, I want to share it to anyone who are interested. So the current tool of cryptography, they cannot offer this kind of service. Cryptography, now they can offer one-to-one secret sharing, one-to-many, but the many is usually not too many. Maybe a dozen or 2 dozens of people is reasonable. If you want to share a secret with thousands or millions of people, then cryptography doesn't work. So anyway, cryptography is a promising tool, but at this moment, not that suitable for big data privacy. So we do need new tools. Do we have new tools? Yes, differential privacy. However, differential privacy is only serving a small part of the privacy landscape. So we do need new tools in this domain. Okay, I think that's pretty much for my sharing. I would like to thank you for your time and listening, and I'd like to take some possible questions. Thank you.
Thank you very much, Professor Dr. Xu Yu. Now we open for question from the floor. Anyone who have question, please do not hesitate to ask. You can unmute your microphone or type your question in the chat box.
Before you ask any questions, UTS welcome all you possible students and colleagues to visit us. We have a lot of Malaysian international students in our campus, so you're welcome. You can also have seafood laksa 100 meters away from the campus.
I see. So do you have any question? Okay, there's no question from the floor. As an appreciation to the keynote speaker, we would like to invite our General Chair, Professor Mahmood, to present the E-Certificate of Appreciation to Professor Xu Yu.
Thank you. Thank you very much.
Prof. Mahmud is here? Mahmud is not here. Then I will. Hello. Thank you, Prof. Xueyu, for very interesting topic. Talk on big data and related with AI. So on behalf of ISTT 2020, I would like to present this certificate of appreciation to Dr. Xueyu for giving the keynote speech in our conference today. Thank you, Prof.
Thank you very much, Mohammed, and the organizers. I'm honored. Thank you very much. Welcome to visit Sydney.
Okay, it's good.
Thank you.
Thank you very much, Associate Professor IR Dr. Huzaimi and Professor Xuyu. Let's give a big round of applause to Professor Xuyu.
Thank you.
We will now have a photo session together with Professor Xuyu. Please turn on your camera and stay smile as I capture for each pane. Muhammad Sufyan, Alif Hakim, Borhan. Okay, smile. 1, 2, 3. Okay, hold on. Hold on. Okay, just smile, okay? Okay, 1, 2, 3. Okay, thank you very much, everyone. We will now proceed with our next keynote speaker. I would like to introduce our second keynote speaker, Dr. Sumesun. Dr. Sumesun is the head of the Communications and Network Department, lead principal investigator of the Industrial Internet of Things Research Program at the Institute for Infocom Research I2R of the Agency for Science, Technology and Research A*STAR. She is also an adjunct full professor with the National University of Singapore. She is the director of ComSoc Asia Pacific Board for the term 2020 to 2021. She's been actively contributing to IEEE conferences in different roles, and the most recent of which include the GlobeCom ICC Management and Strategy GIMS Standing Committee member since 2018. She serves as the editor of IEEE Communication Surveys and Tutorial from 2015 to 2019, and she is currently the editor-in-chief of IEEE Open Journal of Vehicular Technology and a member of the IEEE Transactions on Wireless Communications Steering Committee. Without further delay, let's welcome Dr. Sumesun to share with us on her topic, Cognitive Heterogeneous Networks for 5G, a Unified Design.
Hello, good morning. Thank you very much, Ms. Chair, Lady Chair, for the nice introduction, and also thanks very much for having me here to share some of our work. There is a little bit change to the title of my presentation, so as for us to keep more updated, to look beyond just 5G. So my talk today is going to focus on how are we going to transit from 5G to 6G. Specifically, we are going to look at what will be the key driving applications and also the enabling technologies. First of all, let me check whether you are able to see my screen okay.
Yes, the screen is clear.
All right, that's great. So let's start. then. Yeah, first of all, I'd like to recap with everyone here on the cellular evolution. We know that now we have already been enjoying 4 generations of mobile wireless communication systems before we launch the 5G systems. Yeah, there is some request. So what have we done in the all right. There is someone who wants to do the annotation. Which, yeah, please bear with me first. All right. So now, are you able to see it? Somehow there is.
Yes, doctors, it's clear.
All right.
Just that it's not in the display mode.
That's right. Yeah. Someone requested for the annotation, which is why. Please bear with me. Let me reshare again. All right. So are we good now? Are you able to see the screen without any problem?
Yes, now it's
Okay,
better.
that's great. Sorry for the hiccup. Okay, so let's first recap what we have enabled in the first 4G systems. As a quick recap, we have already enabled voice communications, text, data, web, and up to the 4th generation, we have actually developed the broadband on the mobile systems, and more particularly, the social media on the mobile platform. And of course, it is worth mentioning the smartphone launch, especially by the iPhone in 2007, that has really boosted the development of the mobile communication technologies. And of course, if we look at now, when we go to the 5th generation, it is worth noting that for the first 4 generations, the focus of the technologies, the services have been on connecting people, right? And of course, from one generation to another, we have been increasing the data rates almost by 10 times for each of the generation. And with this, except for pushing up the data rate as a mean to reduce the latency of download of watching higher quality videos, latency has never been a key design specification for the first 4 generations. So moving to the 5th generation, finally, we are looking beyond just the data rates. Of course, the data rate is continually being pushed up to 10 to even 20 gigabits per second of data rate, but at the same time, the other design characteristics or parameters that we are looking at includes the latency aspects. For example, the 5G specification in release 16 has already specified 1 milliseconds of latency under the URLLC, or the ultra reliability low latency communications, to support many industrial applications. And in addition to this, another interesting aspect in 5G is beyond just connecting people. Now we are also putting more emphasis on connecting things. So with that, we can see any applications can be enabled beyond just communicating, connecting among people. All right. So it is worth also recap the three pillars of 5G systems: the enhanced mobile broadband, the massive machine type communications, and also the URLLC. So one very distinctive feature is actually the Internet of Things being enabled by the 5G systems. And for the Internet of Things, or IoT, we have two aspects. The first is the massive connectivity aspect, the massive IoT, and the second aspect is the URLLC, or the critical IoT. So with this, as we have already mentioned, 5G is not only connecting people, but also things. So with these additional entities that we are connecting them, of course, 5G has the vision that it wants to penetrate to all the industry vertical sectors. And of course, with that, what is going to be down the road, it is the enabling technology, or the key enabling technology for 5G in the industrial digital transformation. And indeed, even in this earlier published roadmap, you can see that there are so many different verticals that 5G is aiming to penetrate and driving the advancement in those verticals. And then it is interesting also to look at what we are doing here in Singapore for the 5G. And there are already some of the lead use cases that have been defined and also being pushed forward for Singapore. So for example, maritime, as early as I think 2019, last year, we have already started the trial of 5G systems, both in the C band, the 3.5 gigahertz band, and also the millimeter wave bands for the 5G, enabling the transition of the next generation megapods. Smart estates to use 5G systems, especially the IoT aspect, to actually enable more efficient in energy consumption, and also more smart operations for this smart estate management. Urban mobility through the use of vehicular to everything, or V2X communications, how we are driving it to move to the second generation of the Singapore's electronic road pricing system. And in fact, within I2R, we have been doing quite interesting stuff in terms of connected big data analytics, so as to drive the intelligent transportation solutions. Okay, and of course, Industry 4.0, as we have already seen in the different industry verticals. So Industry 4.0 is another key driving use case that has been pushed forward in Singapore. And it is interesting to mention that industry IoT or IIoT, by using 5G, especially in the URLLC or the critical IoT part, this is going to be a key enabling technology. Of course, there are many different challenges when we actually move 5G into this challenging environment, for example, at the port, or for the maritime offshore applications, and also for the Industry 4.0 applications. All right, so why challenge? If you look at just the picture, you can see already that the wireless propagation will face a lot of issues. example, fading, of course, blocking by many of these metallic architectures in the port, maritime applications, and also in the manufacturing environment. And of course, there are also the key performance indicators that will become even more challenging for us to enable 5G in those industry verticals. So if you look at the KPIs or key performance indicators that have been mentioned by 5G, different applications for example, in the industry IoT, industry 4.0 applications, for example, latency, reliability will be the key driving KPIs as we put here in this table. And some of the KPIs will be really, interesting and costly to enable. For example, this reliability in the cell, in the manufacturing cell automation, we are looking at 9 nines of reliability. So just have to realize this over the wireless channels in those, manufacturing environment. So it is really worth putting in more efforts to drive the adoption of 5G, the industrial applications. All right. So now, with the 5G being deployed over many places already, it is worth re-looking at what are the enabling technologies so as to drive the high performance as promised by 5G. Okay, of course, we have already reviewed that there are three pillars: the EMBB to drive the data rate, and then the URLLC to drive the reliability and the latency, and also the massive connectivity for the massive IoT. For high data rate, it is interesting that we are resorting actually, first of all, the traditional approach that we are going for higher bandwidth. Of course, with the higher bandwidth, we are able to open up more lanes, just as we are driving on the highway, right? So, in fact, a radio spectrum is so scarce a resource. We have no other means of widening the bandwidth but to go to higher frequency. And then for 5G now, over the worldwide millimeter wave band, we are looking at 28 gigahertz. And so with that, of course, a few band can be open for the 5G transmission. But on the other hand, there are also many challenges to use millimeter wave bands because of the much faster attenuation in the radio wave transmission. So to compensate for that, there comes also another key enabling technology, which is the massive multiple input, multiple output, or in a simple term, to use many antennas, tens or hundreds of antennas at the base station, and also tens of antennas, if possible, at the mobile terminals, so that we are again using those advanced multiple antenna transmission technologies or advanced beamforming technologies, we are able to push the spatial domain to offer more parallel beams, to offer more parallel channels, so that we are able to increase the data rate or to increase the connected capacity. There are many challenges to enable massive MIMO for 5G. So it is still a lot of engineering design problems that we will need to address to put a full dimension massive MIMO beamforming technology into the system. All right. So we have mentioned about low latency as one key aspect in critical IoT or the URLLC aspects. So how are we enabling this low latency communications in 5G? Actually, one very worth mentioning and also researching problem is actually network slicing and also software-defined network. Especially with the network slicing, we are able to enable end-to-end guaranteed resource prioritization and also end-to-end guaranteed quality of service so that we are able to support in parallel different verticals of applications and also differentiated quality of service guarantee. So certainly with the 5G technologies and also with its vision to enable into different industry verticals with diverse quality of service, the network management and also the optimization becomes a lot more challenging. So there are actually many different studies on how we are able to push the limit. And out of this design, as I think the first keynote speaker this morning has mentioned, artificial intelligence or machine learning is often resorted to so as to complement what we have traditionally doing in network management and also in the network optimization. So a few aspects that we can look at by using artificial intelligence or machine learning to drive further the performance of the network. For example, the predictive analytics part, so that we are able to have the more guaranteed quality of service, for example. And also with this predictive analytics, we are able to predict faults. We are able to even prevent the fault from happening. And when there is indeed some fault from the network that has been detected, we are also able to, by resorting the advanced optimization enabled by AI, we are able to go for a much quicker recovery of this, this fault or correction of the faults, so that we are able to drive the reliability aspect of the performance in network. And certainly, when we have the data traversing in the network, we can enhance the perspective of context awareness by understanding the traffic pattern, by understanding the user behavior, even to a more finer detail. Of course, without violating, all the data privacy, personal privacy protection. And with that finer detail of context awareness and also the real-time optimization, we could drive for higher availability and also more consistent quality of service for the different applications, either for the human users or for the machines as the users. And certainly, with the adoption of AI, we will need to bear in mind also the complementary design aspect. How are we able to use the AI as a tool to enhance our traditional model that we have already been developing over many years, since the late 1940s in communication theory and also in the information theory. So AI, just as the first speaker this morning has mentioned, is a powerful tool, but when we apply it, the explainability, the controllability, especially when we apply it in the communication networks, will be a careful aspect that we will have to address. All right. So, of course, in addition to the explainability, interoperability, of the machine learning or deep learning, another aspect in the design itself will be where are we going to do this, machine learning or deep learning. Federated learning has been mentioned by the speaker, and it is indeed getting a lot of attention, not only because of the privacy protection, but also as another mean to drive the low latency aspect of the communication network performance. So what we have shown here is actually when we distribute or centralize the intelligence by machine learning or artificial intelligence, the interaction between the edge or the cloud and server will be very important. In particular, when we look at the interaction between the distributed and the centralized intelligence, how are we going to optimize the data sharing between the edge and the central? And also, how are we going to distribute and share the knowledge between the edge and the central? And also, how are we going to update the knowledge and the data? These will be actually very interesting aspects and also challenging aspects. I think we'll still need a number of years of research efforts. Okay, with that, I think it is now we come to take a look at what has been happening in this year of 2020. I think the world is still suffering from the pandemic of COVID-19, but today is a good day in the sense that we finally have received good news of the upcoming vaccine that has been has been reported in the news yesterday. But let's take a look also what has been happening with this pandemic. One aspect to isolate the spread, of course, is all of us or almost everyone in the world has been experiencing this working from home. And certainly with working from home, the support of the virtual platform have been, has been a tremendous support to enable us from working, enabling us to work from home. And naturally, we have seen a huge increase in the network traffic. And more interestingly, that this network traffic increase is not only in the internet backbone, but also in the wireless last mile. Because why? Because many of us will be resort to wireless connectivity, especially for Wi-Fi at home, so that we are able to enjoy all these, high performance of the virtual platforms. So this trend will continue. So 5G or beyond 5G will certainly be coming in as a powerful supporting network solution, so that we are able to, go to the new norm after the COVID. All right. So it is not only for us researchers or office workers to work from home, but also in many of those, traditionally industrialized verticals. And shown here is an example of, a construction site or mining industry. And then for them to work from home, it is not only the traffic or the network capacity that we will need to drive and deliver the support to them, but also, the ultra reliability and low latency aspects that has been pushed even more urgently, so that we are able to support these industry verticals. So if you recall, Release 16 with the URLLC specification was finalized and released in June this year. And usually for the technologies to be incorporated into products, it is going to be another 2 years. So very likely, this will be pushed forward and the product enabling could be shortened. All right. So, of course, another interesting aspect is, when human needs to be practicing the social distancing, then come in all these autonomous systems or the robots into the service, for example, for delivery, for assistance, and so on. So when we deploy so many autonomous systems on the street, in the shops, etc., so there comes actually the more demanding performance in, for example, automated navigation, even higher accuracy of localization in terms of centimeter level of localization accuracy. And of course, fleet coordination, how to coordinate, communicate among the individual systems in the fleet, and also how to avoid collision from one another. So there is also calling for this integrated design of sensing and communications. As one particular example, I'd like to share also as a particular example of this integrated communication system. Here, I'd like to share very briefly a design of a joint radar communication system. We know that traditionally, radar and communication systems are allocated their own spectrum and then are designed using different waveforms for different performance requirements. However, when we look at actually the efficiency of the design in terms of hardware efficiency and also spectrum utilization efficiency, it will be actually driving to look at how do we integrate the radar and the communications solutions into one single system on a shared spectrum so that we are able to drive the circuit, the hardware, and also the spectrum efficiency. So if you look at actually a simple block diagram for radar and for communications, indeed, many of the RF circuit and antenna design could be shared. And of course, it comes then the design challenge of using either the communications waveform or the radar waveform so that we are able to support the other function. And indeed, this is possible for us to look into this integrated design system. And shown here is a design study of the 11AD waveform, which is actually a cyclic prefix enabled or supported either OFDM or single carrier waveform. And at the same time of supporting still the gigabits per second of data rate, we are also looking at optimizing the design so that we are able to use this 11AD waveform to support localization, to support the radar function. So for example, if you transmit the 11AD signals from the source vehicle to a target vehicle or from a source robot to a target robot, and then the reflected waveform will be reaching the source vehicle. And for the radar processing, we could use this reflected waveform and then do the rendering and also the localization. With that, alert could be given so that we can integrate the multimodal learning so as to give this anti-collision performance in the integrated system. So indeed, this is possible, and also there are still a number of challenges that we will need to address. For example, how are we able to, as I mentioned, even enable the communication capability by using the traditional radar waveform. Even though, in that case, we may not be able to support a gigabit level of data rate, but some of the critical information could still be embedded in the radar waveform so that we can, support a mission critical and low latency communications. And certainly another aspect is, the enabling of multiple radar communication devices in the local network. And in that case, the interference mitigation will be a key design challenge to address. And certainly for the joint radar communication systems, it is a full duplex system design. So the the conventional problem of self-interference cancellation in the full duplex system will still be valid, and it is actually even more demanding when we actually are looking at using this full duplex system for target localization with high accuracy. And of course, when we look at a MIMO system or massive MIMO system, then the beamforming design in the joint radar communications with the support of multiple beams for the two applications, for the two purposes, will be another interesting research problem to look into. So without further ado, now it is good time for us to look at with the design target of 5G, with these new challenges introduced by the current pandemic, and also moving to the new norm after the pandemic. What will be actually the invasion 6G system, 6G applications, and also the 6G enabling technologies be like? So first of all, let's take a look at actually the published 6G white papers or vision papers. The first one shown here is actually the published white paper by Samsung in July this year. Their white paper is very interesting. It is shown that it is titled 6G, the next hyperconnected experience for all. And for all, as you can see from this view graph, that it is not all the people, but also all the machines, devices, vehicles, and so on and so forth. So with that, of course, there are actually the performance limit that needs to be further pushed in terms of data rate, in terms of efficiency of energy, and also spectrum, and also latency, connectivity, density, and so on. And there are also a number of candidate technologies shared in the white paper. For example, we have nowhere to go when we push for higher data rate with higher bandwidth. So in addition to the millimeter wave bands, now we are pushing, or as predicted by Samsung, we are pushing to even higher band spectrum frequency of terahertz or the sub-millimeter wave band. And of course, antenna, duplex, beamforming, interference handling will still be actually in the mainstream of the enabling technologies list for 6G. Interestingly, when we move to even higher band spectrum frequencies, the network topology may be worth rethinking. Another aspect of the network topology is when we enable or incorporate AI in the network design, in the network management. How are we going to also rethink the network topology so that the AI can be integrated more natively and more efficiently? Another interesting aspect with the limit of time I was not able to share much is actually when we enable wireless operations for the industry verticals, for example, in Industry 4.0 and so on. High precision network synchronization will be a key aspect that we need to push to. And in this aspect, we are talking about, tens of nanoseconds of network synchronization accuracy, so that we are able to coordinate the fleets, coordinate the different machines for collaborative operation. So it is worth actually looking into that if you are interested. Okay. So another quick sharing of the 6G vision is from Huawei by this keynote presentation from their chief research scientist based in Paris, Professor Daba. So coincidentally or cohesively, is also innovation that 6G is going to be the enabling technology for hyper-connected world, but he's adding also the intelligent aspect of this connected world by 6G. So to put it simple, in this hyper-connected intelligent world, everything, all things will be sensed and connected. And in addition to that, everything and all things will also be computed so that we are able to make all of them intelligent. And of course, integrated together, all these things will be supporting us to drive into an intelligent world. So some of the key technical aspects will include like broadband, higher data rate, and then computing, big data, and also AI and IoT. So with that, we are moving to the 6G in another 10 years time. Just the same time frame being predicted for each generation of the cellular evolution. Some of the performance targets when we move from 5G to 6G, again, there is this traditional higher data rate performance target. And in addition to that, we are also driving, interestingly, in the Huawei prediction, we are driving actually higher precision in terms of the network performance. I mentioned briefly just now in terms of the network clock synchronization, and shown here is even more specific of performance in terms of the jitter of the network clock synchronization. We will need to push to around 10 nanoseconds of jitter. And then the positioning accuracy is another aspect of higher precision. We are talking about 10 centimeter level of positioning accuracy. And certainly with this, we are able to push really 6G to connect everything, to sense everything, and also driving the intelligence in all the different aspects in industry, in living, and also in working for the next wave of technology and also technology innovation. All right, so as a quick summary, some of the research problems includes, but not limited. One aspect is actually when we make the machine as a key user, so how are we driving, the massive connectivity with the URLLC kind of QoS support. And for these machines to operate intelligently, cooperatively, the high precision network synchronization, the wireless time sensitive network aspect will be another key driving technology development that we will need to actually move forward to. I mentioned briefly that we will need to look into the joint sensing and communications design. In fact, in many of these operations in industrial sectors, we could actually augment the joint sensing communications to also include computing and control in the integrated design. And how are we going to model it and then drive the optimization will be an interesting and challenging aspect as the enabling technology. Certainly, AI is, one important actor in the 6G design, and in particular, how are we going to make AI native in all the different layers of the communication network design, and also make it explainable and controllable. And so the network is going to become much more complex when we move to 6G. So the agility and flexibility so that we are able to, reconfigure on the fly of the 6G reduce the network, and it will be critical. And more interestingly, another aspect, through the introduction of the large intelligence surface, how are we able to also make the environment reconfigurable and agile by introducing this large intelligence surface so that we can make the environment to support the communications need. So antenna will be continuing as an important aspect in the design. And last but not least, how are we going to integrate the privacy and security and also the reliability aspects into the design and coupled tightly in the different layers of the network? I think it is going to be another key driving research topic to enable 6G. So what is the roadmap like? Just as any of the earlier 4 generations, it is about 10 years when we are moving from the current stage of early 5G deployment to the 6G ready deployment. So there are actually the standardization aspects and also the research aspects and the key enabling technologies aspect. So hopefully by 2030, we are going to welcome another 6G, and then we are moving to another exciting development, and also seeing more transformation enabled by our area of research work of networking intelligence. So with that, I'd like to take this opportunity to thank your attention and also thank the organizing committee to have me here and share some of our work and also some of our vision. Thank you very much.
Thank you, Dr. Sumaisun. Thank you for the valuable sharing. We now open for Q&A session. Anyone who have any question, please do not hesitate to ask, or you can unmute your microphone or type your question in the chat box.
Can I have a question?
Okay, there is a question from Sharifah Kamila. Dr. Sumaisun, the technology is ready in the preparation for 5 or 6G, but are the people of the world ready or need the technology?
Yeah, thank you for the very good and interesting question. As I shared earlier in the evolution roadmap, starting from 5G, the attention is really moving toward also connecting not only people but machine. And the vision of 6G is actually not only the machine, the sensors, but everything. So it is really, making it coherently integrated into the different things or machines, so as to bring us the convenience, not only the convenience to people, but also pushing the the transformation in the different industry verticals. for example, in manufacturing, in transportation, etc. And that, I think, will be the even more powerful driving force when we move from 5G to 6G.
Thank you, Dr. Sumisen. Thank you, Sharifah Kamila, for the question. Okay, we have another question from Dr. Chun Yo. Any
Yes.
research topics? Okay, sorry, yeah, please, Doctor.
Okay, thank you. It's a wonderful talk, Sumi, as I have learned a lot. I want to, two questions. What's your opinion about security privacy in 6G? And the second question is, it seems that previously for the communication students, the computing students, we are separate set of skills, right? In the future, does that mean our students, they need to learn more to be suitable for the 6G? Thank you.
Yeah, thank you, Sri, for your really very I think thoughtful question. I was actually enjoying your talk just now. You mentioned actually many of the challenging problems in security privacy design and also the research. One interesting aspect, I think, when we move to 6G is in addition to the traditional privacy and security design in data, in the networking, but also it will be, I think, will be another driving force for us to start thinking about how are we going to protect the communication sessions beyond just the traditional, authentication or the crypto design itself. So we have been talking about physical layer security, signal embedding in the waveform design so that we are able to have like another keyword for this is covert communications. So it has been staying in the research stage for many years. But when we move the wireless communications or 6G to support so many different machines and sensors, I think it will be timely to look at how are we going to integrate, and enable this in the lower layers of secure communications design. In terms of skill set for our students, for our next generation researchers, indeed, I think it is a very good question. I'm, however, not able to have a very straightforward answer because it is also a puzzling question for me, right? We have been for me, I started from, the wireless communications, and gradually we pick up new skills like machine learning, which is actually part of the statistical signal processing. Of course, we are enlarging the data dimension, and also we are enjoying the more powerful computational resources. Then for security integration into the communication design, I think it will also involve maybe rethinking of the information theory itself. So really, how are we going to, drive the knowledge and at the same time, not overloading ourselves? This is really a very, a very interesting aspects, I think.
Okay, thank you very much.
Okay, Dr. Simison, we have question in the chat box from Dr. Chen Yo. Any research topics for AI in 6G? As for 5G, we're already seeing that AI used for network optimization.
Yeah, I think I don't think I'm able to have a exclusive list of AI in 6G design. But some of the aspects that we have been working on, for example, the explainability of AI in network management and network control, resource optimization. I think this is one key problem, research problem for machine learning or AI in network. Another aspect, we have been working on is more related to fast learning and quick convergence in the fast changing network scenarios. We have been actually experiencing this challenging problem of taking tens of thousands of epoch before we are able to see the convergence in machine learning or deep learning. And then when we apply it in the real-time network management, this is not going to be acceptable, right? So how are we, able to improve the performance in this aspect? Maybe another interesting problem to look at. We have also been looking at, using machine learning or deep learning to look at network monitoring, to look for anomalies in the network, in the system and the device, so that we are able to predict the faults, predict anomaly. And with that quick prediction, we are also able to quickly prevent the anomaly or the faults from happening. It is going more to the firmware and also the higher layer network management aspects. Just to share a few examples. Yeah, thank you.
Okay, thank you, Doctor. We have another question. So what is the benefit of 5G or 6G can gain for the third world country? As for now, seems that the developed country benefited the most. So what's your opinion on this?
Right. I think if we look at, of course, for those developing countries, there will be other driving needs or more urgent needs to address. For example, enabling the ICT, etc. But on the other hand, I think if we are able to really realize even the vision of 5G we are talking about 5G to enable digital transformation. But if we look at another perspective for these developing places, I think they have actually a unique advantage of leapfrogging, bypassing all the transformation need, but starting from a greenfield approach, and then they can start with a highly efficient and highly connected implementation of, connected agriculture, connected manufacturing, so that they can start with a much higher latitude to drive the efficiency. And with that, I believe they are able to enjoy actually all the learning curves that we have been experiencing. And so it could be another perspective when we transform the technologies to the places. I think it is premature. It is a very deep thought question, but thank you for this very inspiring question.
Thank you, Doctor. So we have another question from Dr. Haizuran. So for 5G, it would be having frequency of 3.8 gigahertz or millimeter wave of 28 gigahertz. In addition, the bandwidth is 100 megahertz. How about 6G? What will be expectation of the frequency carrier and bandwidth?
Yeah, so thank you for the question. I think right now for the 5G, just as you have pointed out, we are looking at 100 megahertz per channel. And then we also have actually the flexible carrier aggregation that has been specified in the 5G standard. And then moving to 6G, the current discussion has been focusing on pushing toward even higher spectrum, like the 300 gigahertz band, in which we have actually even wider bandwidth that we can tap on. Again, it is not only the bandwidth itself, but also when we move to these higher frequencies, the propagation characteristics will be another, perhaps advantage for us to leverage on, because the signal will be attenuating much faster. So we may be able to really form personalized and individualized cells, right, by containing the signal, containing the interference, so that we are able to push for the network capacity even in a different, network topology perspective. So, yeah, I hope that I have answered partly your question, but also I'm hoping that we can look beyond just the spectrum and the frequency allocation to push for the network capacity.
Thank you, Doctor. Okay, maybe a last one. Which country is the leading for the 5G, and which country are actually ready to face the 5G and maybe 6G?
Right. Yeah. Thank you for the question. I don't think I will have, the most up-to-date data with me. But, from the news, certainly, I think a few places are leading the 5G deployment. Among them, like Korea, China will certainly be ahead of many countries. And then Japan, US have also, been pushing the 5G deployment. I think it's a matter of also, like in Singapore, for example, we have already finalized the spectrum allocation. There is also the roadmap already actually put in place for the telcos to avail the 6G services. I think these are some of the the information I have offhand. But as I said, if let's say we want to really look at the statistics, there will be actually more rigorous collection of data needed. Thank you.
Thank you, Dr. Sumesun. Thank you very much for the overwhelming questions.
And thanks, everybody.
Okay, now, as an appreciation to the keynote speaker, we would like to invite our conference chair, Associate Professor IR Dr. Muhammad Huzaimi Juso, to present the E-Certificate of Appreciation to Dr. Sumesun.
Thank you. This is very wonderful. Thank you very much.
Thank you, Prof. Sumesun, for very wonderful, wonderful and informative speech. Then I believe all of us, all the participants, gain more knowledge and the very valuable inputs from your morning. So on behalf of ISTT 2020, would like to present this E-Certificate of Appreciation to Prof. Sumesun for giving us the keynote speech this morning. Thank you, Prof, for your sharing.
Thank you very much. And thank you for having me. I enjoyed the session very much. I wish the conference a good success. Thank you.
Thank you very much. Okay, over to you, Azlinda.
Thank you, Associate Professor IR Dr. Muhammad Huzaimi Juso, and thank you, Dr. Sumesun. Let's give a big round of applause to Dr. Sumesun.
Thank you very much.
We will now proceed with the photo session. So as usual, please turn on your camera and smile. Nur Azlina, can you open your camera? Ayman Dia, Hafizal. Okay, smile. Smile, 1, 2, 3. Okay, hold on, one more. 1, 2, 3. Wait, I haven't changed to the next pane yet. Okay, the next pane. So please just smile because you guys don't know which pane you're in, right? Okay, smile. 1, 2, 3. Okay, thank you very much, everyone. Okay, so now we should proceed to our agenda. But before that, we will have a break. So we will resume at 11:15 a.m. for the industry forum. So we will have 15-minute breaks. Okay, so we hope you guys can gather back at 11:15 a.m. Okay, thank you. Thanks a lot for your attention and thanks for the participation. So we'll meet again. We'll resume back at 11:15 a.m. Thank you.
Hey, you okay?
I was trying to find a strong Wi-Fi signal.
Well, look at all these things. They affect your Wi-Fi, you know.
What things?
The microwave oven, items with reflective or metallic surfaces, all these can cause interference. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
Welcome to Multimedia University, the first Malaysian private university. In 1997, the Malaysian government took steps to transform the Malaysian economy from one that was goods and export-centric towards one that relied on digital technology and emphasized services. Since its establishment, Multimedia University has grown in size, in stature, and in impact, both within Malaysia and across the globe. Now, Multimedia University is widely regarded and trusted for its innovative and useful programs. The university is trusted by the Malaysian government as well as numerous professional, governing and assessment organizations across the world. Their trust is expressed in various rankings, agreements and partnerships with the university. In fact, MMU currently holds a unique position as one of the most preferred universities across various industries in Malaysia. This preference is a result of years of hard work as well as the intrinsic nature of MMU. From the get-go, MMU has made it a point that it is part of the international community. It drew talent, input and the knowledge from across the globe, and its deliverables were also to be enjoyed worldwide. Another important aspect is MMU seeks to future-proof its graduates. By opening the doors of entrepreneurship to its citizens, MMU seeks to help lay people to improve their economic standing without relying on existing job creators or even on existing economic models. Furthermore, by thinking in terms of helping various industries secure better qualified personnel, MMU has been able to come up with cutting-edge academic programs, some of which have no parallel within the country or even the hemisphere. Thanks to this nimbleness, MMU has been able to help Malaysia break into new areas of national interest, which include financial engineering and content creation. Of course, MMU graduates are so sought after not only for their strong technical know-how, but also because their strengths go beyond their academic obligations. Our academicians are also active. Throughout the years, they have collectively proven themselves to be very prolific, not just within the confines of academia, but also in the development of the respective industries. In short, MMU has led the private higher education sector in Malaysia for more than 20 years because it has played an active role in the development of the nation. Where other institutions teach, we inspire. Where other institutions draw a map, we take the leap forward. Where other institutions opine, we do. The future is filled with uncertainty. What is certain, however, regardless of the myriad of issues that face Malaysia and the world, MMU will be there to help its students, graduates, as well as its community find a solution.
It's me. I just don't know how to relate to you.
It's not that hard, you know. It's like any other relationship. The better you know your dual band router, the better you can connect to your Wi-Fi. A dual band router lets you switch between two frequencies, whether you want speed or coverage. For gaming or streaming, 5 GHz will give you faster speed but within a shorter distance. But when you're further away from your router, switch to 2.4 GHz for wider coverage but slower speed. That's how you can enjoy drama-free connections anytime. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
Bismillahirrahmanirrahim. Welcome back. Now we will continue our symposium with the next agenda, which is the Industry Forum, with the topic of In Manner of 5G, IoT, and COVID-19. This is an interesting topic to be discussed, aligned with the crisis that we face today on COVID-19 global pandemic. Let me introduce our panelists. We will have Professor Dr. Tariq Abdul Rahman from School of Electrical Engineering, University Technology Malaysia, UTM, Dr. Kirat Pal Singh, Chief Data Scientist, Aziata bin Muhammad, Faculty of Electrical Engineering and Built Environment, University Science Malaysia, USIM. Allow me to share their short bio. Professor Dr. Tariq Abdul Rahman served the School of Electrical Engineering, University Technology Malaysia, UTM. He is the advisor INT and Future Networks Working Group in Malaysia Technical Standards Forum, MTSFB. He plays a key role in developing 5G Malaysia initiatives. He connects the academia and the industry, forming effective collaborations and partnerships. This includes the engagement with Japan's 5G Mobile Communications Promotion Forum, 5GMF, and Korea's 5G Forum, which promotes knowledge transfer and the collaboration in 5G research and development. Our second panelist is Dr. Kirat Pal Singh, who is currently the Chief Data Scientist Aziata. He has worked as a research consultant for Philips Consumer Electronics USA, managed regional radio and network operations for Celcom Malaysia, and was a Chief Technology Officer for international organizations that provide mobile applications, develop interactive television platform, and content aggregation platform. Dr. Kirat Pal Singh had filed 3 patents pertaining to mobile enterprise platform, public safety and big data processing, obtained LTE certification, professional cloud architect certification, and was awarded gold medal for invention in the area of local-based services. And our moderator, Professor IR Dr. Hafizal bin Muhammad from University Science Islam Malaysia, USIM. Professor IR Dr. Hafizal is the recipient of Asian Outstanding Scientist and Technologist Award 2017 and the Top Research Scientist Malaysia by Academy Science Malaysia. Professor IR Dr. Hafizal has more than 20 years working experience in the ICT industry and telecommunications research. He is passionate about creating a hyper-connected world. Prior to his academic position, he was working as senior staff researcher at Corporate Technology Division Mimos Berhad, where he involved in projects related to Internet of Things, cognitive radio, and mesh networks. Without further delay, I will pass the session to our forum moderator, Professor IR Dr. Hafizal bin Muhammad.
Thank you very much. Welcome everybody for this session, Industry Forum in manner of 5G, IoT, and COVID-19. We're going to discuss issues that related to IoT, 5G, as well as how things has changed with respect to the current situation, the pandemic that currently that we face. So I would like to thank Prof. Tariq for and also Dr. Karatpal for allocating some of the available time to be with us today. So I would like to encourage everybody to think about what are the questions that you have in mind. You can write the question in the meeting chat. You can post the question there. Then Prof. Tariq and Dr. Karatpal will try to address this question. As introduced by earlier, Prof. Tariq has a lot of experience related to wireless communications and 5G. So I'm going to start the session by asking Prof. Tariq to give an overview about what is the status of 5G in Malaysia, because Prof. Tariq is involved with a lot of activities with MCMCs as well as research in UTM. So Prof. Tariq.
Thank you, Prof. Faizal. So, Assalamualaikum and good morning. So, I think thanks for inviting me to share about the related to the 5G and also AE for this ISTT 2020. So, the question that Prof. Faizal asking about what is the status of the 5G in Malaysia.
Yeah.
Okay, I think currently I know that we have more various inventions from the 1G before and now to 2G, which is the digital data and the text, and to 3G where it started, that is the 2000, and then further to the 4G, where we're talking about the increased performance. And we come to 5G, as you see, basically not only just the broadband, but also we are looking at the things. You can say from horizontal to vertical. We create more other opportunity or verticals in the application. And as we know that all those generations are being mission and requirement are set by the ITU. And for the CUTP, the one that are looking into the standard application. And in Malaysia, basically, we work on this standardization or system back in year 2000 in IM 2000, where the standardization been done in ITU, but that time we form under ITU Malaysia before MCMC, and we try to adopt the standard what being specified in ITU. And then we move further to the 4G. As you know, 4G is the IMT advanced. And again, the standard forum in under NTNC is the NTFSB, National Technical Standard Forum, where will be their task is to get the standard, to adopt the international standard that been approved as a Malaysian standard before we can apply in Malaysia. And I think for the 5G, the same thing happened, which is IMT 2020. As already, I think the vision was set earlier by ITU back in 2011, 12, and also 11. And then from there, doing the standardization and ongoing further maybe from the IMT A1. And as you know that in Malaysia, the NTFSB is also a body to endorse the technical code and also the standard for the 5G. And I think recently the working group under NTSB called known as IFM, IMT Study Works, has already completed the generation of this code, machine code based on what been specified in GPT, release 15 system, and also has been presented to the MCMC, and I think now it's currently in the process of what we call accepted or the endorsed by the MCMC. So the current status is that but we will be adopting what have been standardized or being accepted in the standard body like PGPP, where that one have been endorsed by the FDA. Okay. Well, that is the status currently.
Yeah, thank you very much, Prof. Tariq. Very comprehensive answer, covering a lot of areas and also activities that are related to 5G in Malaysia. So I'm going to move to the next question. Maybe while other participants thinking about the question, so I'm going to move to Dr. Keratpa. So perhaps you can provide a little bit about background of respect to IoT and also big data. What is it that is happening in the industry in Malaysia, Dr. Keratpa? Maybe some of the things that you can share related to your current activities.
Hi. First of all, is my audio clear?
Yes, good.
Okay, all right. So there are a lot of big data and IoT use cases right now. So for example, in telco, in telecommunication company, we use big data to study anomaly detection. So for example, you have a 4G network, and then if you rely on the vendors, you will only get to know when the signal has degraded, when there is a down alarm. But with data science and the capability that we have currently with data engineering, we can actually stream the data in and study it via near real time. The reason sometimes you can't get things on real time is because you need to store more information, your base station information, your other type of information that you are capturing. So anomaly means that whatever regularly that you have, let's say in a given seasonal day in a cell, maybe near your university, right? So you will see a trend during the school days or during classes. That's a peak at 5 o'clock in the morning, 6 o'clock. I'm just throwing out some numbers. So maybe that's because people wake up early and do their studies. So when you suddenly see a peak or valley, so then the system detects and say that, hey, I need to send this notification to the personnel to go and look at it. So it's more of a machine being trained to learn and capture where are the anomalies happening in your system. So this is what we call an anomaly detection, real-time anomaly detection. You can use it for telecommunication, and then I'm sure for companies that are like providing band, also deploying similar capabilities. And of course, there's a lot of interesting algorithm that goes inside there. You can take machine learning algorithms. So for IEEE, I'm sure there are a lot of journals that are being published in the area how we actually detect, because you want to prevent sometimes false alarms, and it's not easy actually, because at times for example, your historical data has been captured for the past 3 months, and suddenly something happened like COVID, and you assume that the area is still, having the same characteristic, and suddenly nobody is in that area. So how do you actually determine that something a change has happened? So you need to actually retrain your model, and then you need to put it back in production. So this is one area, I would say. So other areas like in telecommunication, of course, now there's a lot of competition between telecommunication providers, and in fact online companies that do a lot of online selling, because now with COVID-19 people are not going to uh, go and do a lot of shopping outside, so they will use Lazada, Shopee, and all that. So sometimes you will notice, even like Amazon, right? You go in and say, I think I suggest you buy this. So those are like recommendation engine, and how they learn It's all due to the capabilities of machine learning and also the recommendation models that are being put in. Some models are quite straightforward, some models are quite complicated, but it all goes back to how you store your data. So in order to answer more questions on this area, if you think about 5G coming in, so you will have a higher speed, and this will actually help you to transport more data to where your machine is, and even allow your edge computing to have that kind of knowledge to make a decision on that spot. But talking about the great stuff about real-time anomaly detection and all that, I'll also share with you some secrets, right? So the recipe here is, it's all good. Machine learning is good. The data that we get in telco is good. But then you have to imagine that not all data arrives on time. So sometimes you have to wait for certain data. Some data, they are not full. They have a lot of null values inside. What do you do with those null values? Some data are corrupted. Some data could be actually dependent on something else happen, during transfer. So all these kind of effects, and there are some other noises also that's happening. So people always say, oh yeah, it's good, telcos implementing it, we can get the information real fast. But then again, how do you retrain? How do you know that a time series is actually correct for that seasonal pattern? And of course, human behavior changes, and then there are many other factors. So even recommendation engine also, when you talk about, okay, let's buy this product, that also depends on how many people have contributed to provide this kind of information to your system, right? So that goes for recommendation engine. And again, data engineering is not that simple, because you have a lot of sources coming in. You need to train your system with all these features. The more features you have, the better it is. You don't want to overtrain your system. Sorry, you don't want to actually overfit your system to provide the prediction wrongly, or you don't want to give it less samples. So again, that's why they call it data engineering, data science. So I have seen some interesting articles, journals. So when I remembered many years ago, I think 10 or 15 years ago, when I was doing some research on neural net, I used to remember I run, my laptop crashes because I can't put a lot of data inside, because that time I remember having a 2 gig or 4 gig of laptop is like, wow, that's the best you can do, right? Now, even if you have a 32 gig, you say, oh, that's not enough. That's not enough. So then what do? We need to go to the cloud. So another topic I want to also uh, um, instigate upon all of you, right? So now we talk about 5G, we talk about IoT. So we also have this PDP Act. We also have the GDPR policy that's going to be implemented in the European countries. So then who is going to provide data? Who is going to collaborate with us? Maybe a telecommunication company can look at its own signals, right? Can look at the network, because it knows its own signal. But then when you want to collaborate, you may want to collaborate with the government, you may want to collaborate with universities. How do you do it? You don't even have a framework to actually anonymize those data. So those are certain things that, are challenges actually when you want to make your model quite intelligent. So for example, if I want to know that I want to do a seasonal pattern of this area, and that area consists of more people that are in the uh, uh, industry, or they are in an area where the demographic profiles are more of white collars, or it could be an area that it's probably predominantly an academic area. So then the profile that currently we do is we scrape it from internet, and of course, those kind of profiles are as good as a good indication, but it's not what we actually want. So there are some challenges too. So basically, I'll hand it back to you.
Thank you. Thank you, Dr. Karak. So because you have a lot of experience in the industry, so it's good insight that you have provided. So I'm going to give an early opportunity for anybody around here. Participant, we have about 39 participants. If you have any question, you can voice out, you can shout, or you can type in the meeting chat. Any question that you have before we move on? Okay, so all right, I'll move to the next question to Prof. Tariq. So, this pandemic come without any prior notice. So it just happened, and then how does it affects telecommunication, maybe telecommunication industry, or how does it affect people life respect to COVID-19 and 5G, for example? So how do you see that whether technology can be of help to make citizen life, for example, to become easier or in dealing with the pandemic?
Okay. Right. Okay. For that, I think maybe I should start off with the Malaysian perspective from what's happening. As you know that our plan before in Malaysia that I'm talking about introducing the country. They have showcase in Putrajaya last year and also some demonstration just to demonstrate the capability what the 5G can do. Because when you talking about 5G, people get always confused that 5G. Some of them complain that even 4G not yet been fully like they are going to the 5G. Basically, I think that's why it's very important for the people to understand really what is the 5G difference or what is the difference between 4G and 5G. And also again, as you know that this demonstration that we done in Kuala Langkawi and we're just demonstrating some of the difficult. As you can see that basically we're looking into changing 4G more towards speed, more towards the broadband. They move to 5G. Not only that, that's why we're looking into the enhanced level of the broadband. If you see in 5G, there are three triangle there, UNDB, as you said, that's 4 million earlier. Then we also have infra-reliable low latency, where the latency is reduced compared to the 4G capability, where we can create new verticals. For example, we need to do digital healthcare automation, autonomous car, and so on. And also other thing is the message machine type communication. It's related to IoT, and so on. They require massive. We're talking about the feature that in the million of devices per square. And then when it comes back, then government also has proposed this ISTT. I think we talk about the National Coverage Connectivity Plan, where because the connectivity planning that we are talking about to get at least 30 megabits per second at 98% of the populated area, which means it's cover urban, and even the rural area and so on. But what happened after that when this COVID-19 coming, you can see that when that's happened, you can see that the internet traffic has increased. I think it increased 30 to 70%. And second thing, what's happened is that the internet use moved to the residential area because many people work from home. And that one you can see about 50 to 70% increase in the residential area. And again, you can see also what happened here is that the internet speed reduced. It can reduce, and then you can see also there's a lot of complaint from the in terms of the coverage outdoor, even indoor, and also some of the speed. Okay. So with that, I think what the looking back on the NSCP program into what they call it as the Jindela. I think most of us heard about that being proposed or by the NCC and also the ministry, where the general basically an output from the lab that been done I think in August, for 2 weeks, to come out what will be how we want to overcome the issue of connectivity, the issue of coverage. But we are not talking about the coverage only. We are talking about the quality as well. And then from there, they come out with the what we call the outcome that they want to have the digital infrastructure and coverage, and then also for the improvement plan to reach the coverage and the quality. And another point is that to have this optimization of the resources, meaning that what the resources that we have, like for example, the spectrum to achieve the national aspiration. Maybe I can tell you why the national aspiration that the government supposed to come out with one we are looking into gigabit for fixed broadband, meaning that they have to expand further the fiber to both the beside urban suburban and also the rural area. And then also they are talking about 100% 4G coverage, meaning that to optimize the current 4G to get to 100%, and also the speed broadband is at least more better than 100 megabits per second. So all these aspiration, the national aspiration, all are looking into preparation or foundation for 5G. That's why they put into two phases. First phase from now until 2022, try to achieve those aspirations. That means their target now change from for 4G coverage, they need to have 96.9% for 4G coverage in populated area. Second, talking about the speed now, they are looking at 35 megabits per second from the setting in NSTP. And also, they are looking into the what we call, it is the connectivity in terms of the fixed broadband, the fiber, and so on. That is what within the 2022. That's what I think the focus. But the expression after 2022 would be when you have a gigabit or fiber, you're talking about the current status, the fiber to premises about 4.9 million. Now they are targeting to 7.5 million, but the aspiration is to get at 9 million. So when we have fiber, most of the places, implementation of 5G is easier because most of the 5G needs fiber. The second thing, basically, we're talking about optimizing the resources, meaning that the spectrum that used by 3G currently, which is basically 900 and 2100 megahertz, will be upgrade to 4G, meaning that all the 3G, as we know that what the government initiative from that is to sunset 3G by 2021, meaning that the spectrum that they have on the 4G, all the service provider operating the 3G has to be moved to 4G to optimize. And then the aspiration is to have 100% 4G coverage. So why we're saying that, because by having 4G, when you want to implement the 5G, maybe after 2022, that means that you can have what you call first stage of 5G is NSA, non-standalone, where you can have maybe the core level of 4G, we have a new review of the 5G. And also the new site, the upgraded, and also the new site extend to get the coverage, all has to be 5G ready. So these are the things they think. And also, I think one important thing I can share here is that one of the expressions to get from general is you can have the what we call the digital map. I mean the consumer can check at those locations how is the status of the coverage, how the status of the speed, and so on, and then you can complain that, and then to the service provider to ensure they can improve to achieve that. So this is what I think after COVID.
That would be good, because then the coverage will become more transparent to public, to the users, because at the moment we don't with the map now we know better about the coverage and also improve the quality of service for the telecommunication networks. Thank you, Prof. Tariq, also sharing the national aspirations. A lot of activities are going through. So I'm going to pick up one question from our participant here, Amirul Shahril. So I'm going to pose this question maybe to Dr. Kerakpal first, and then Prof. Tariq can take up if you have any answer for this. So the question is that based on panelists' point of view, which 5G use case will start in Malaysia and which use case will be the most popular? So I think he wants you to pick up, for example, one use case. So there's a lot of vertical for 5G. In your opinion, which one will start, pick up in Malaysia? So there are two parts of the question. So yang pertama, which one will start? And then later, eventually, which one will be the most popular? So in your view, maybe Dr. Krak and later Prof. Tariq or anybody. Okay, maybe Krak start, yeah.
Okay, all right. Actually, that's a very good question. In fact, it's a golden question. And you wanted to have one answer, but I can only give from my opinion, right? Yeah. So basically, from my opinion, is that like what Prof. Tariq mentioned, that currently there's still a lot of optimization work going on the current infrastructure, whatever we have. So if you want to actually look at 5G, how would you benefit 5G? So you need to actually leverage on its capability. So whatever use cases that works very sensitive on latency, and whatever use cases needs availability, 99 point many nines at the back, right? So those are the use cases that you need to actually work on. So for example, people talk about autonomous vehicle, autonomous cars, or anything autonomous. So even if you have your IoT sensors located and it needs to make decision based on some quick communication information, right? Or even if your car is autonomous, so can you have a full coverage that is actually providing you with this SLA, stating that maybe, let's say in Klang Valley, you wouldn't have a point where your availability is below certain threshold, right? So that's number one. Number two, latency. Can you have your decision be made in within milliseconds, right? We are talking about milliseconds. Of course, in microseconds, that's awesome. So to do that, your 5G network has to be very scalable, stable, and it needs to have a very good handover. Even maybe to a certain extent that where your cloud or your processing is located, it needs to be able to connect to it real fast and be able to make certain decision. And I'm talking about infrastructure. So let's then look at cloud. Let's say you want to put everything on cloud. So then what infrastructure do you want to use in cloud? So if you say, oh, okay, I think I have a lot of read and writes, right? Because this is an IoT system. So then you need to make sure your IO is good over there. So now you have a good 5G providing you maybe in the next several years. Then at the same time, the cloud is maturing. So then you say, okay, I can even do telemedicine, or I can even now do autonomous vehicle, or I can even have sensors that talk to each other. So the use cases would definitely be interesting right now to talk about, anything that's autonomous. Of course, you hear about autonomous cars, and at times they make wrong decision and accidents happen. So that's very unfortunate. So fine tuning and all those are really still happening. And of course, network plays a big part. The computing plays a big part, cloud computing. So it's not only your 5G, it's also your cloud computing. And of course, your algorithm that goes behind it, right? So how would you want to make your decision? Do you want to use deep learning, or do you have some novel way of calculating something real quick? So that's where we as engineers, scientists, researchers need to go back to our research environment and do more and more testing. So that's something that what I can share. Yeah.
Okay, thank you, Dr. Kerapal. Prof. Tariq, do you have any view? Your view on this 5G
Okay,
use case?
okay, Afiza. you can see now at the moment, you can see the early use cases for application of the 5G more towards B2B, just to use like the whole industry, not much really toward the consumer, but B2C, for example. But I think one of the things that, from my experience, is very important to the, I'm looking towards how the people can benefit from that. The rakyat, the orang, people from the remote area, rural area, and all these things. So one of the things, once, that's why we say that the first phase is to make this infrastructure. Because you see, I can share you also the minister. I think the ministry have talking about after this happened, the infrastructure had to be improved, infrastructure preparation for 5G, what we call the optimizing the resources, using the spectrum, and also to address the new normal. For example, that's what happened now in COVID-19. And one of the applications that I see, once the some of the fiber or the fixed broadband can be put in place to some of those areas in rural area, for example, you can have, for example, you can have this application, you can have 5G only at those locations. For example, we have clinic data there. And then you can have a tower that having connected to the fiber, putting the new radio 5G over there. You can have one of the use cases, for example, remote consultation. So meaning that the people in the kampong area, they don't have to travel to the city or other places where they can go to their clinic and the specialist or doctor can be somewhere else. Because this 5G network can support, for example, 4K, 8K, as if you are visiting the doctor face to face, I mean in France, so what we're doing now online, for example. But you have since the 8K, 4K, 8K resolution can be supported with 5G, so that can be. This is why I think that one of very important that benefit. Other than that, basically I'm talking about like in the factory, autonomous robotic and all those things. Even when you come to a case where we have a full implementation of with the latency of 1 millisecond, you can have one of the things, the remote surgery. For example, the doctor can be like even what happens now also, you can see in some hospital, they have this what you call microscopy, something that when you want to do operation, don't need to operate, you have to what you call the robot will be in the doctor in the next room will be controlling the joystick to the operation, but that thing is connected to the cable because the latency is important. Whatever the movement done by the doctor or the joystick, the robot who operating the patient that will be by this 5G latency 1 millisecond, reliability 99.9999% of course. It should be capable. Doctor can be anywhere. So meaning that the simple application that the microscopy I mentioned to you also already available in some of the stations in Malaysia. But this 5G network, we have that. Maybe there are some critical cases where we need specialists to do that. But that required not because of the distance and so on. But this is one of the applications I think maybe it can benefit the people, help decide what we have more towards B2B, where we are talking about automation, we're talking about other things like autonomous car and remote control, all these different things that we have. Yeah. I think that's my, I think that.
Thank
And,
you.
and
Thank you.
one more thing, Afiza, that's why I forgot to mention that now the internet is important, connectivity is very important for the people. We're looking into this demand is just like a utility, one under the third utility. As you know that electricity, water, but now I think recent budget has also announced that the internet connectivity, also the broadband is considered as one of the utilities. Right? You
Yeah.
consider when you are doing any the areas of
Okay, thank you, Prof. Tariq. Yeah, that's very true because I think if there is no internet at home, it's almost like there's no electricity nowadays because you cannot do activities in respect to the work and also
Because,
communication.
Prof. Hafiza, not only the connectivity in terms of the coverage, we're looking here in the quality. That's a very important two things. coverage and the quality. Say
Yes.
example, you have the water pipe to your house. But what happen when you open the water is very slow. So you will be very
Low pressure. Okay.
enough. That's why I'm talking about 35 megabit, but the next time talking about 100 megabit.
Yeah. Thank you. Very good perspective from Prof. Tariq. Okay, I'm going to pick up another question from Nur Azlina. Yeah, I think there are two parts of the question. So I will read. In the research team, developing a wireless system model constrained on the reducing error probability, high-speed data transmission, and computational complexity. So that's the background. Is there any claim that 5G development might harm, weaken the human immune system, especially during the pandemic? I think the first part is about the ongoing research that being carried out by many people, from my understanding. So developing wireless system model constrained on reducing error probability, high-speed data transmission, and computational complexity. The second part is that is there a claim that 5G development might harm or weaken the human immune system during the pandemic? So I think the second part of the question is more about the effect of 5G towards health, human health. So maybe either Dr. Karapal or Prof. can comment on this.
Okay. Prof, maybe I can start. You say something about the first part, the first question related to error probability. So when you're looking into the error probability for 5G, because it has to be ultra reliable, low latency, meaning that the probability of error has to be very good. And then you have to prepare for the gadget. That's why I prepare because of the reliability. Yeah, because reliability is very important. Because you're talking about doing the remote, for example, remote surgery, remote all those things. Yeah? And the second thing related to the effect of the more toward the health effect of the 5G. Okay, always people will relate that 5G they are using the higher band, millimeter wave band. Basically, 5G cover all the band. Like you see that 2G, 3G, 4G, they are talking about below 1 gig, lower band and mid band. I mean below 6 gigahertz, what you can see now. But only the 5G they have to cover lower band for the coverage. For example, one of the application in the 5G is the message machine type communication, which is IoT, where that then some application of the sensors, they don't require bandwidth, they don't require latency. Latency can be very high, but they require massive and also long sensors to be long battery life, coverage to be wider. That's why lower band is very important also in the 5G. Second one, they're looking into the mid band. Mid band is a 3.5, which means the band that above what we have in the 2G 2.6 now. But the issue now is that 3.5 basically coexist with the assessment, the services that there has to be, because the 3.5 is the most what you call popular ecosystem. Most devices are available there because that will provide capacity and coverage. When you look into lower band, is basically coverage. Mid band is coverage and the capacity. But the higher band in the millimeter wave, currently we are talking for 5G, 26 and 28. They will be a small cell, maybe around 200 and 300 and so on. So with this, you can see that when looking to lower band, maybe the tower or base station related is maybe roughly same as what the 2G or 3G has. Again, in 3.5, not much different. But when looking into the millimeter wave, the base station will be 6 meters, meaning the same like only 200 meters. So will be a lot of things, and then people might worry or worry about whether this has any effect and so on. Then maybe I can touch on it because this is all radio frequency. When you look into radio frequency, they extend from 3 kilohertz to 300 gigahertz. So the frequency they use in 5G, the highest millimeter is only currently 26 to 28, which is much lower. And you're looking to the effect of the what you call the health radiation, for example, because in the electromagnetic spectrum, which cover radio frequency, infrared, what you call the sunlight, even the visible light that you can see. Then you can have infrared, ultraviolet, X-ray, gamma ray. Okay, and this spectrum that categorized under non-ionizing is up to visible light. I mean, even the sun that we see every day, we can feel the radiation of the heat, which is but that's still under non-ionizing. The most dangerous one is ultraviolet. For example, even the sun they have some ultraviolet that can cause skin cancer. X-ray, also the gamma ray. And people worry about the even 5G, even 2G, 3G radiation, the power, the effect. You see, important here is the energy, electron volt. If you look into the term of energy that can expose, non-ionizing means categorized because thermal effect, meaning the temperature range. Like you are in the sun, you can feel hot. So what happens to your body would try to sweat to recover that. You know, the energy from the sun is 1,000 times more higher than energy from the electricity. So if you are worried about radiation or anything that can be, then you have to worry about having take the sun. You can feel the heat because the energy that they have 1,000 times less than the and what it can do is just why positive because our cell consists of the electron surrounded not by proton when you are being exposed by this they will be vibrating that vibration positive but they don't have enough energy to cause ionization activity. That's what happening in radio frequency, infrared, up to sunlight. When we go beyond that, they call not ionizing, then the energy has, X-ray 1,000 times much higher than sunlight. That's why when you expose, then they can have some effect. When it can cause ionization to happen, that's what radio frequency is. But you were worried about when you do X-ray, what happens? Of course, X-ray. But X-ray, as you see, the doctor put a very low dose, which means and not a very short snapshot and so on. But your body can recover. But ultrasounds, okay. Maybe in the day they can still survive because low frequency energy. But the mother with who what you call baby inside cannot because that's why X-ray when you are pregnant you cannot do the X-ray because the baby is too small to recover back. They put a low dose where your body can recover back. But you have to do the X-ray. It's no choice. So this is my opinion. I think the issue of effect of the I think still more even according to the WHO and also the ISTT set the standard for non-ionizing, there is still the study doesn't show effect that can cause any problem. That is part for my understanding.
Thank you, Prof. Tariq, for your clarification. Yeah. Dr. Karapal, you have any view on this effects of 5G or radiation on human? Or
I
everything
think
has been covered by
yeah, Prof. Tarek has mentioned quite in detail. So I think I will just pass that question. On the first part, yes, there is still research going on to study how we can reduce error speed and of course the high speed capability. So that one, of course, people are always talking about 5G, 6G. So the research community has a lot of important significance in improving it. So I think
yeah.
that
Okay, Dr. Karapal, maybe another question that I can throw to you while waiting for others if there are any other question. Others, I will encourage you to ask question because it's not easy for you to meet with these two great gentlemen to ask a question direct to them. So please take this opportunity. So my question to you, Dr. Karapal, so it's a lot of in the literature. So we are moving a bit on towards the research part now. So a lot of things in the literature that I see, the use of machine learning and also artificial intelligence to optimize the telecommunication network or cellular networks. So perhaps you can highlight maybe some of the challenges in the industry or what is your view with respect to, for example, algorithm that can be used to make 5G or the next generation cellular system become better?
Okay. So if you can, by the way, you can hear my voice, okay?
Yes, yes.
Yeah, I've seen your picture frozen on my screen, so I just got worried. Okay. So basically, if you talk about machine learning, you talk about AI, this field has been there for a very, very long time. So what I can say, when you're using machine learning, it has been made very simplified right now, just by writing a Python code. You use your Jupyter notebook, or you can use Cloud to write your Python code and execute your program. Run it on GPU, TPU, CPU, or whatever, right? So how does it benefit a telecommunication company or any other companies out there? Even retail, Lazada, Amazon, many others. Even AirAsia is using machine learning, and all the industries. So machine learning, when you go back to basic, it means that how do you train your automated machine to understand human intelligence and to respond as immediate as possible. So that's the benefit of using machine learning, right? Rather than using a batch processing and then later on use rule based. So if you just use your rule based algorithm, then you will not be able to adapt to incoming changes. So here in this way, you can adapt to incoming changes because you need to solve real-time problems, solve whatever given to you on the spot. You need to automate. So that's why we have machine coming in, and AI is of course the whole aspect of this machine learning, right? So if now we have 4G and we are optimizing it, we are already putting machine learning in, but again the challenges is the data quality, whether we are storing, the data in terms of what we want to do, whether you have the right data that you want to train your machine. So, for example, like in human child, you can train that, oh, okay, there is a dog is bad, right? For example, it will bite you, right? So some kid, they grow up, they say, oh, a dog is very loyal, so then it depends on how you train. But in general, what you need, it's sometimes you need to customize that training for your company to be able to recognize the uh, the category yes, no, or do something. So for example, I saw this one good example. Google, they have a very good API, right? Vision API. So if let's say I'm a telco and say that I want to use Google Vision API and I want to detect all the antennas, even without knowing what model they are, by just looking at it, because I've been training a lot. So maybe Google's API will fail because they do not have that type of pictures in them, because they can only recognize the normal general things that people have given. So in that particular case, you train something customized to your environment with the pictures taken for your environment. So then it will save time. So here, when you come back to machine learning, the algorithm that being used right now is quite simple. So the community, the IEEE researchers that are here today, so there are still a lot of room for improvement, right? In terms of how do we build in better algorithms, how do we integrate with whatever's outside and work on something novel. So algorithm, computational detection, all that is still pretty much required. Is there any other shorter way to find out, right? Or do you really have to use deep neural network? Maybe not. Maybe sometimes certain things can be trained very easily. You can have a hybrid. Maybe a simple linear regression can do for this problem. You call a deep learning to do something else. So there are many other hybrid that you can use, which people are using. Okay, so now when you have a 5G network, and then you rely on your network vendors to tell you when system is down, or or maybe you want to tell when the quality of the signal is low, which is still very tough, very, very tough, because I cannot be crowdsourcing and get the customer complaints and say that, tell me when you are really angry with the service, right? So in terms of machine learning, you have good, bad, right? So a lot of times when you have data sets, you have skewed to the right. Let's say right is your good, your bad is little. So you are training more on the good and less on the bad. So there should be a way when we improve even in 4G, we need to collect more samples when they are bad, either through crowdsourcing, either through some other method, either through people giving their feedback in some ways that's very constructive. So you can use that data, or you can use the data that probably sent to MCMC or whatever. I'm not sure, but it should be in some ways that you're able to improve the quality. So immediately when your sensors or your IoT or even the mobile company detects that there is a slight degradation, they will say that, oh, the degradation is normal, or the degradation need to be alerted immediately for the personnel to go and check or do something about it. And everything can be also automatically corrected, right? Can be self-healing if it's some network. So I think these are the areas of research and academic thinking that we need to put in, and also the think tank that needs to work towards the data. So for example, I think government is producing open data, right? So, but there are some data sets that you might be interested to do research on and you are not getting it. So what do you do? So if you want to improve quality, like I mentioned right now, if you give me all the places that people have complained, the long lat at the time and the signal level, then maybe I can put it to my machine and make it understand that this is bad and this is good, and what do we do? So yes, data is very, very important. How do we collect it? How do we actually work towards it? Because data is not easy. We have PDP, we have GDPR. We cannot simply just go and ask people that, hey, give me your data when it's bad, right? So it's not an easy equation. Even though scientist wise, I would say go to the web and then go to a Kaggle competition, and there are a lot of data sets. Go and play with it and go and do some of your own innovation. But again, sometimes you want to work in a reverse way. You have a problem statement, but you can't get the data. Then what do? You cannot be creating dummy data, because you need to have that actual situation. And to get the actual situation, the data is not available. So that's where we need think tanks, we need government's help, we need some kind of spearheading, maybe a university or somebody leading it, and say that can we please get some subset of this, and they should be probably either some IoT company, OPCO, or some network company, and say, okay, I will donate this data for the past 2 years that probably you can use, if that's okay with you, because 2 years is quite a long time back, right? So something like that. I think those are the challenges, but when you get it, it's awesome. Your machine should be able to capture that and should be able to process, and of course you can employ whatever algorithm, the current algorithm that's out there, or your own, or something else, right? Or hybrid.
Okay, that's good. Thank you, Dr. Akbar. So maybe the next question that I would like to ask maybe Prof. Tariq. So let's say we're going to have 5G. So are we going to retain 2G, 3G, 4G, and 5G, or are we going to shut down one of these G, kill one of these G, and reuse the spectrum, or what would be the ideal setup for the next generation cellular? So, or is it possible to let all these generation to be used by people, or you need to kill one of these G to move ahead,
Okay.
to optimize the spectrum protocol?
Yeah, so thanks for that. It's very good question and very important question. To see what happens to the 2G. You know that 2G is still now available 2G, 3G, 4G, now we are moving to 4G, 5G. But that's why the aspiration that the government or the even the part of the general, first thing they want is first optimization their resources, meaning that acquisition their spectrum. Like you know that spectrum is a very scarce resource. You have to utilize it more very efficiently. You don't want to make that spectrum that not be utilized, not efficiently to utilize. That's why they have in the first phase of this general by 2021, the government already have decided 3G has to be sunset, meaning that there shouldn't be no more 3G service after 2021. So now the task force already been formed from the regulator and also service provider to look how this can be phased out. Rather, because when you see 3G, first we see talking about 2G and 3G have to phase out. To move to 4G to optimize the 4G towards the 5G. But since currently there are things like sensor, like machine to machine and other, we still using the what we call the 2G or even the 3G or 3G. So if that's why they decided that 2G still can be maintained to support this. 2G meaning two things. So one of this machine to machine and all still available like in bank and all these things still have to be maintained. You cannot stop. You cannot, otherwise there will be a problem. But 3G is you can sunset 3G because 3G, as you know, they occupy WCDMA occupy 5 megahertz respectively. You want to implement 3G, you need at least 5 megahertz. Without 5 megahertz, you can't. Yeah, but with 2G, you can have 200 kilohertz with 8 times short. And then this can be used for the machine to machine highways to require very low data rate, not much required. So they think that. But you have to sunset 3G because if you can reuse the spectrum of 3G at 900 and 1800 currently being used by the telco, you use for 4G, one thing you can get 3 times more efficient. Meaning that in the same spectrum, because of the technology from CDMA to OFDMA, they support 3 times or even more capacity. That means you can utilize the resources more. That's why one aspiration is to sunset the 3G and to optimize the 4G, meaning that increase the site. That's why the target in the final aspiration is to have 100% 4G coverage. But 22, meaning we require 96.9%. Currently, they have 91 something 0.8% of the 4G coverage, and 3G coverage at the moment is about 1995 something, 95.6% like that. If you can convert the 95.6% of the 3G plus what the existing 4G you can have a lot of capacity, and then you can extend further. So that is very, then I think in the future, slowly they will be migrating all those IoT things using NB-IoT, for example, we have in the 4G. The only issue now is that of the, the 4G, they require packages. I mean, for voice, the voice goes through voice over IP. But most of the time, currently, when you make a voice call, you can see that from 3G, you fall back to, from 4G, you fall back to 3G. After you finish your call, you go back. Because two things here, either the device doesn't support the voltage, or the service provider doesn't provide IMS, the conversion in the packet for to the PSTN. They need to have that. But now, within 1 year or before 2021, end of December, all they have to all this. Okay, before. I think future, what we see that 4G and because 4G, 5G are together. We need step towards 5G, at least you can have 4G 100% coverage. Say you have fiber, you have 4G coverage, you can implement 5G in area. Because when you need capacity, for example, in NDB, I give you an example in an area, say there is a stadium there. At the normal time, other times, it's okay, capacity is enough. But when it comes to any event, something, then capacity is good. Then the 5G can support into of that. But of course, in future, you need to extend further when you're looking into 100 megabit average per user in the next aspiration. So future, I think whether we'll be looking into 4G, 5G, and Wi-Fi. These are the three things there will be. 2G, 3G slowly will be phased out. You can see most of the countries will phase out because utilizing the spectrum. 900, they have 700, 850, 900, 1800, 2.1, 2.3, 2.3. If you can utilize the spectrum more efficient, more in capacity, then you can, no? So that is my 4G, 5G, and Wi-Fi will be the future. Yes.
Thank you very much, Prof. Tariq. Okay, a question to Dr. Kratpal. Within the discussion that we have, we didn't touch much about IoT. So perhaps you can, if you have any things, because I know your work more on data analytics. Is there any development in the industry with respect to IoT, or how do you see IoT is being taken up by the industry in Malaysia?
Yeah, hi. On the IoT arena, I think there are still a lot of room to grow because I it's all about right now. What happens is IoT is a lot about collecting and then sending the information and maybe a little bit about interpreting the result, right? So if you look at the industries, a lot of time they collect and they do not know what else they want to do about it because we need to have subject matters in that area. So for example, you look at agriculture, right? Smart agriculture. So the sensors that some people put it there, they get the info, and then from the info, they need to have a very strong SME to say that I think we need to change the sensors type. I think we need to get more of this type of input. Then they may want to bring in more of the data scientists to look at it from the data scientist perspective because the data scientists, data engineers, and the people behind the scene that interprets the data need to have this SME to actually advise them that this is what's required. So currently I think we don't have much of that SMEs, but we have very good IoT capabilities. I think we have IoT devices, and then we also have the infrastructure to actually provide IoT. But what goes after that? So if there is not much connectivity between these devices to the interpretation of the data that what you need to do, or just for the sake of like, oh, okay, this one has gone above threshold, this one has gone below, and then that's it. Okay, I think it's time to go and harvest your rice field or whatever, right? So if it's just that, probably it helps definitely, because you don't want to send a lot of people to a remote area. It helps definitely. It doesn't optimize. So when it doesn't optimize, where you can actually do more out of it, then I think there's still a lot of room to grow, especially in Malaysia. It still required the SMEs to be very deep in the field. It can be agriculture, can be whatever areas. It can also be transportation. Of course, you heard about how sensors are being put in vehicles, and they have sensors. But again, insurance companies are saying they're using that. So yeah, I mean the pickup rate is definitely there, but we want to see more. We want to see that how it's integrated with the academic research, right? So now we have the data, but again, I said that this bridge is a bit tough. Would they want to share that with an academician and say that can you go and do a research beyond whatever you just received, or do we just stop here and say that okay, we got the data, that's fine, we see that this driver is a safe driver, and then there should be also integration to other kind of systems probably profiles and also weather reports. So there are still some silos of data. So we get some in, some we are not getting. So I definitely think that the room for improvement is a lot in Malaysia. If we can somehow work with the government and come up with a framework, I think we can in fact spearhead a lot of interesting research and pioneer in many areas. I think you probably have heard like our neighboring country like Thailand, they're using IoT and then of course in some of the West countries they're using IoT even in agriculture. So yes, I think it's there, but if you ask my personal opinion, I would like to see it more and more algorithm should come out of this and even leverage on our research capabilities to put it across, and integrate with the different areas. Because I always believe even in data science, you can champion one area, right? But you need to also get information from the other areas. It's just like a human. We learn something, okay, by knowing that your crop field has changed color. It doesn't serve a purpose for that sense only. We also need to say, okay, let's look at the weather pattern. Let's look at the temperature. Let's look at whether it's time to sell this crop now, or can we store it, or what's happening with the world economy, right? If do we want to store this longer period because now the price is cheap here. So there's a lot of other data that you can actually combine together and make your system more technologically efficient. So
Yeah,
this is my
thank you.
view.
Thank you very much, Dr. Karapa. I'm going to give a last opportunity just now, the first opportunity. So this is the last opportunity to anybody in this conference call to ask any question that you have, either verbally or using the meeting chat message. So I have one last question to Dr. Karapal, and then I'm going to ask last question to Prof. Tariq later. But okay, I have one question here from IR Dr. Nordin Ramli to Prof. Tariq before I ask the last question to Dr. Karapal. So Dr. Nordin asks to Prof. Tariq, what is the issue of what is the issue of the sunsetting the 2G/3G? So maksudnya meaning that we are sunsetting 3G, for example. What are the is there any problem? Is there any things that we need to address before we shut down this 3G, 2G?
Okay. Right. Thanks, for the question. Yeah, for Faizal, I think sunset first, they are looking to TV sunset, as I mentioned earlier, because taking into the account that all this, the machine to machine, feature phone available, and the fallback of the voice call, because more of the time you can see that our call is fallback to the second stage, either in 2G or the 3G. So then decided, I think the level decided that to make the 2G sunset first. And the issue is that maybe talking about the phone, the device, because some of the devices, that's why I think now the regulator and all the Syrian and the Islamic are working together, and also the ST to educate or to inform there won't be any no more 3G phone will come in from now to today, and then those phone the has to be the new phone there where you have phone it has to be working capable. Meaning that when you can use the voice because usually working is much better in terms of voice quality. We're talking about voice quality and clear all that is much better than that. The only issue maybe is that the current one that has the phone, they say the one then they can still use the phone for voice call, they fall back to the voice call by maintaining the TV. So that's why the TV sunset will be done later. And the second thing is that because why the 3G come first? Because 3G using these resources, 5 megahertz of the spectrum. You need to have 5 megabit, otherwise you cannot implement 3G. So even we have low capacity, low user or high user, the amount of spectrum is the same. Whereas that's why 3G is necessary. So now they are very aggressive looking into how to ensure that phase by phase is a quarter by end of 2021 all 3G has to be closed. I mean sunset in terms of the all the from the all the telcos. So that is the and then is it second question? I forgot that. Is that the question asked?
Yes, yes, that is good. That is the question. Yeah, that is about sunsetting 2G/3G. Thank you, Prof. Tariq, for the clarification. Same. My last question to Dr. Kerapal. Because we have, I don't have the demographic profile of our participant here, but I guess maybe some of the participant here is young researchers. So perhaps they want to become chief data scientist like you. So what it takes to become a chief data scientist? A very general question. So what is your role, for example, and then what they need to equip with themselves to become a chief data scientist?
I think basically it's all about experience. So of course your institution, educational background that you have studied helps a lot. So I think we are in the right track here. IEEE, right? So I'm also from the EE area. I studied in US and I did my degrees there. So basically when I came here, I started working in a telecommunication company. So the first job was actually to become a datacom engineer. So wherever I work, there's always data inside, datacom. So providing services, either compressed data, and you know that it was in the 1990s. Even if you have data of 200k, it's considered, or 512, it's k 512k is considered high. So what we do, we practice a lot of compression. So you guys probably, some of you who were there during those time, you remember E1, right, which is 2.048 meg. So now we are talking about gig, right? So that day we had to use a lot of ways how to make sure that we compress. When we have a small E1 link, how we compress. So there was that time. Then after that, I got into IT. IT, you learn a lot about databases and services. Then you learn about, you apply more on programming skills. So then when I was in MIMOS, I got a chance, actually there was 2012, I got a chance to actually lead on the big data projects. So big data was very, very new. So I jumped into all this open source Apache. Of course, I had a good team who were very willing to jump into all these areas. So if I want to tell all of you guys, look at open source and always have an open mind. And I know now time is for, it's COVID time. So some of you may say, I'm bored sitting at home. But as you know, we are researchers. We are also a practitioner. We practice that. So if you feel like there's some research that you can't do, then go ahead and study something else. Maybe look at AWS, look at GCP, look at Microsoft, see how they are, organizing their technology stack platform. In fact, you can actually go and register for free labs like in Quick Labs and play with those free labs for 1 month, and you get to know about IoT. There's an IoT core. Very interesting. There's a lab, I think I just completed. One lab is about an hour, 1 hour and a half. So do those kind of experimentation, get some extra skills. So when you get to know about data, you get to know what's outside. So then eventually when you go and work, it doesn't have to be in telco. It can just be in any industry. So let's say you're interested, you become a data scientist in Shopee. So then, after a few years, you become a senior data scientist. Then they say, wow, this person is very resourceful. Then maybe it's time for you to lead a team or time for you to spearhead. Then you can look into the chief data scientist, or sometimes they call it the head of analytics, or maybe vice president of analytics. So those are some of the career path I can suggest to you guys. But basically, being you can see that the distinction between developer, IT, and also data scientists is that data scientists not only need to do thing, but they need to think beyond coding. What am I going to achieve? So you are training the machine, right? But before you can train the machine, you really need to know your hypothesis to achieve that goal, whether it can be achievable or not. So then you use your data, and it provides you with some kind of experimentation results, and from that results you say, okay, I think it's time for me to productionalize this, or maybe no, I need to look at different algorithm. So that's where uh, the knowledge and experience comes in, because a lot of times, when you talk to business related colleagues, they will say that, hey, how much accuracy is good? You don't ask the question about how much accuracy. It's all about your data. It's all about how you use the algorithm. Do you do any parameter tuning, and what is your optimum level of getting the right data to make the decision to generalize something, right? So if you show me a picture of English alphabet from A to Z, and I can't even read the B alphabet correctly, and you give me a lot of that B sets to read, and as a human, I always get it like 80% correct, then you can't expect a machine to go more than that. So then there are some things that you learn as you go along. It's experience, it's also reading. And also another thing I would like to suggest to you guys is that sometimes don't think more on just the position. Think about your own satisfaction. If you love to do this type of job, right? Because sometimes when you are a researcher in an academic institution, you may say that, hey, I want to see what's happening outside, I want to practice it. So if you love what you do, automatically, your career path will follow with you. So be happy with whatever you're doing, be happy with the research, right? And
Thank
of
you.
course, I just want to highlight a few things. There are no ideal world, right? So even in data science, sometimes we end up, we give up and say, hey, machine cannot do this judgment, I gotta use my normal rule base, right? So you have to be prepared for that. Sometimes there are days that you are not motivated. You may say that, hey, my research don't work, then I have to fall back to whatever others that I've learned in my school days, or probably in some other journals that are saying something interesting. So yeah, there are some, rainy days, and there are some sunny days. So this,
Okay.
right?
Thank you, Dr. Grappa. There's one question from Dr. Azwan here before I go to last question to Prof. Tariq. To Dr. Krapal from Dr. Azwan, SCADA sensor, TMB, etc., mainly using 2G or 3G as for now. Customer will have to spend quite a considerable sum of money to move to 4G/5G. Will the commercial price of the be the same if customer are asked to move to a better technology? This is a commercial
Okay.
question.
Okay, if that's okay, that question is if you ask me, right, from my opinion, okay, being in a telco or not telco. So as you know, the business is getting competitive, right? So we cannot penalize customer for giving them 5G, whereby we feel that whatever our ROI for the 2G network has been laid, and it's definitely, your return of investment is already there. But now it's also an obligation, right, to the country, that all the opcos are doing 5G, right? So when they do 5G, uh, the cost of acquisition, buying all these new stations, and those equipments are going to be expensive, right? Even if you have those smart meters, and that comply to that. But of course, if it's just the infrastructure, some of the equipments can still fit wherever it is. So it's just an infrastructure upgrade. But again, every opcos, every company, they need to also see what's viable to survive, right? So if they give something really expensive and people cannot afford, or people are complaining, why I can't have my old price? So there should be a compromise. There should be a compromise that people see that it's a value, and the companies see that they are able also to sustain. So it has to be a win-win situation, and therefore definitely sometimes government will step in and say that I think this is a recommended pricing, or there should be a ceiling. So I don't think that the cost will definitely be passed to us. So as a consumer, I will myself be angry that if I just want to know my meter, right? I would rather have it in Port Malaysia sending me, or either the TMB sending me the bill, and if it's cheaper, I would rather opt for that option, right? So why would I want to go to 5G? I mean, definitely, but again, it's a compromise between the industries, compromise between the consumer, and there should be a point that both parties, consumer and also the business sense, make viable for them to take up that specific pricing.
Okay, thank you, Dr. Karapal. So last question to Prof. Tariq, because we have about 5 minutes to finish. We are almost 1.5 hours in conversation with Prof. Tariq and Dr. Karapal. So my last question to Prof. Tariq, you have you obtained your PhD before 2G back in 1988. You obtained your PhD about 30 something years ago, and then you have lived through generation of 2G, 3G, 4G, and 5G. From research or from maybe industrial perspective, what are the challenges moving from one generation to the other generation? Or perhaps another way to put the question is that maybe you can give like a personal perspective of what you have gone through from 2G in terms of research until what it is now is 5G.
Okay. For that, okay, as you mentioned, I came my PhD during the first G in the year 1980s, lah, you can say that. And then it's happened that I'm doing my research work related to mobile communication. Then I came back and moved from 1G to 2G. And it happened that when I was in VTM under this research center, or research lab there, yeah, I'm also involved because it happened that the 1G is basically a country standard. Basically, you have UK tax system. Even in Europe, you have different standards. NMP is federal country and so on. Then we moved to 2G in year 1990. Is basically based on the regional standard, meaning that like GSM is European standard. Japan is using PDC, and also the US has different ISTT and so on. And then when it comes to the 3D, and you see that the issue of the previous standards, basically the roaming, when you move from one place to other place, is a different standard internet with that. And second thing, the internet coming, the broadband is becoming good. First generation, you see just a voice. You don't record no data at all. When it comes to second year, we have voice and text, SMS and OGPRS and so on. When you go to 3D, basically when you're talking about 3D, we are talking about two things. First, you're looking into the global standard, which means and then the second thing is talking about the broadband. That's why the requirement in the 3G is that you need to have at least 2 megabit, and also you have to. That's why ITU take over. ITU start is at that time customer is not one. It happened that being funded by the NTT Docomo to get involved in the standardization. So I get involved in the standardization of the 3G at that time in the year 1996-97, where meeting report, because since they set the requirement, they had to be endorsed by ITU because this is consensus, meaning that all the standard body, all the countries come before they come out with that. Of course, ITU want to have one standard, but it not happen because to be network compatible to 3G. And then that's why when they endorse the first standard in the, I was there, which is in the Finland, where they endorsed release 1999. I get involved 4 years before that. They have various meetings, you know, different countries host different meetings. And then it's interesting to see how it come out, based on the input, the plenary and all these things to get consensus. They call release 99. Then the first release that is called IMT 2000. And then of course they changed the name to 19 release 4 because they don't want to follow the year. And after that 3GPP take over to improve further. You can see release 5, 6, 7, 8, and also come back to when it comes to all release they're using WCDMA, the technology. When it comes to the next level, release 8, then they have to change the technology to get more efficient, more spectrum in going to OFDMA. And then again, ITU set the vision, the requirement, the vision back in 2003, 2004 for the 4G. They said that 4G should be 1 gigabit for low mobility, 350 kilometer per hour you travel at 100 megabit. That is the requirement set by me. But of course, the technology of that's why you say that 4G you can be optimized to get that. But you need, of course, a spectrum. You need to have 100 megahertz and so on. Then when you come to that release 10 meet that requirement. You need a release 10 there are two technology that meet the ITU vision and requirement. This is YMAC, and also INT1. And then move further to release 11, 12, 13. Then again, ITU set the vision for the 5G. Back in 2012, 13. And in 2015, when they endorsed the specification, I also attended that. That's why they want to have, that's why you can see the triangle. Enhance further the broadband, because 4G is supposed to can support 1 gigabit, with low mobility, 100 megahertz of spectrum. That is one thing. But not only that, they are looking into now latency, 1 millisecond latency. They are looking into IoT, message machine type communication. Okay, and then this will go through. Then 3GP is working further to release 15, 14, and the IoT when they want to talking about IoT, is done in release 13, where they're using the narrow band of this to using the LTE then to support the things for instance. But of course, the next step will be the endorsement of release 16, 15, as well as 16 and 17. That is 5G 2020. But now, as we heard earlier in the keynote, the next coming is the 6G. And it's interesting to see this happen every 10 years, every decade. 1980, 1990 is first generation, then second generation, 2000, third generation, 2010, fourth generation, 2020, fifth generation. And coming one is maybe next, another 10 years, which is 2030. It's 6G. That's why I from the academic point of view, because you have to do the research based on what, and then the collaboration is very important, internationally and so on. But what my suggestion for the academic researcher to do now, they have to look forward on the 5G, 6G. 5G is no more. 5G has been done before, where you're looking into that. Now 6G, you are important 6G, especially what I can share. One thing is related to the spectrum. 6G, maybe you're looking further to terahertz, above 100 gigahertz. So we are looking into that aspect, very challenging. One thing is challenging on the propagation. What happened at that it's very important to study to see the propagation effect and all those things. And also the antenna. Antenna become very small. And then that's why I think one thing important, if I can share last was 1 minute that means 5G, you see, you're looking into 3G, 4G, they are using Omni, the base station, okay, or satellite. You just transmit depend on the height, depend on frequency, the power you give you the coverage. Then the user will be not. But when you look into 5G, what is the thing that is the most important thing most people do? What is the MIMO? Be informing. You know, it's just like a spotlight. And this is very important because you see, if you have a normal 3G or 4G, your signal coverage from the base station is fixed. That means if you are close to the base station, you have good quality. You move further, meaning that your signal will also degrade. I mean, your capacity will degrade. Not based on the law. and so on. But with 5G, we have beamforming, then you focus to whether you are close or the farther away, signal quality is the same because they have a way. And then beamforming, every user has different. And related to the EMF, basically 5G is much better because you don't require to transmit high power from the base station. The power transmitted from the station to the user is just good enough. If you move further, then increase the power and so on. So which means that it's not like a light that you have in the room to cover the whole room. It's like a spotlight focusing to you. What you require is the number, enough that you can read. That is the thing that happens. So this is the state. And then you go further, talking about frequency, propagation, antenna, massive, and so on. So that's
Thank you very much, Prof. Tariq. Very interesting perspective of 40 years of 40 years of development from first generation until 5G and also some suggestion about 6G. Okay, I'm very sorry that we have to stop here. We are 4 minutes over time, injury time, as they call it in football. So thank you very much, Prof. Tariq Abdul Rahman, for sharing your thought and also experience with us today. And also, I would like to say thank you also to Dr. Karapal Singh from Axiata for allocating your time with us today. So I'll pass the session back to Dr. Melinda. Thank you very much, gentlemen.
Thank you.
Alhamdulillah, thank you very much. Thank you very much, Dr. Tariq and also Dr. Kirapal. What a lively discussion. There is so much input that we can gather and obtain from this forum. As an appreciation to the panelists, we would like to invite our ISTT General Chair, Associate Professor Dr. Madini bin Rosli, to present the E-Certificate of Appreciation to our forum panelists and moderator. Let's welcome Associate Professor Dr. Madini to present the E-Cert to Professor Dr. Tariq Abdul Rahman.
Thank you.
Assalamualaikum and many thanks to our industry forum panelists and moderator today. We have Prof. Hafizal, Prof. Tariq and Dr. Kirapal Singh. And my thanks also to our industry on forum chair, Dr. Azban and Dr. Ashraf. That's working very hard in inviting our panelists and moderator today. On behalf of IEEE ISTT 2020, I'd like to present an e-certificates to our forum panelists today as an appreciation for the delivering the interesting forum sessions. Thank you very much, Prof. Izal, Prof. Tariq, and Dr. Kirapal Singh.
Thank you.
Thank you so much. It's really an honor to be in the same panel with all of you and the professors.
Okay. So for me, thank you for Madini, also for Aina and the secretary for inviting me for this session.
Thank you, Dr. Madini, and also the organizing committee that worked very hard to make this event happen.
Alhamdulillah, thank you everyone. Let's give a big round of applause to our forum panelists. So we will now have a photo session together with our forum panelists. So please turn on your camera. Okay, turn on your camera, please. Okay, smile. 1, 2, 3. Hold on. Okay, another one, smile. 1, 2, 3. Okay, thank you so much, everyone.
Thank you. Thank you so much to
Thank you so much
organizers.
for your attention today. We will take a break for lunch and we will resume our symposium at 2 p.m. Before we dismiss, there are a few announcements for the presenters for this afternoon session. The afternoon symposium session will be held in 2 parallel sessions, so please make sure you enter the correct link and prepare with a working microphone. Thank you very much.
Prof. Dr. Kirapa Singh, thank you all.
Thanks so much.
That's it. Thank you.
Okay. See you guys. Thank you.
Thank you. Thank you.
just don't know how to relate to you.
It's not that hard, you know. It's like any other relationship. The better you know your dual band router, the better you can connect to your Wi-Fi. A dual band router lets you switch between two frequencies, whether you want speed or coverage. For gaming or streaming, 5 GHz will give you faster speed but within a shorter distance. But when you're further away from your router, switch to 2.4 GHz for wider coverage but slower speed. That's how you can enjoy drama-free connections anytime. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
For 60 years, University Technology Mara, or UITM, has been the place for acquiring knowledge and developing capabilities. From a training center to now a vast network of universities, UITM has campuses and faculties all over Malaysia. UITM allows for the pursuing of goals and earning a degree in any field of choice, with a mission to enhance the knowledge and expertise of Bumiputras in all fields of study, through professional programs, research work and community service, while upholding moral values and professional ethics. Nestled amidst the greenery and some of the most scenic areas in the country, each university campus is strategically located in places where their presence inevitably provides an economic boost to the local community. The Vice-Chancellor is the Chief Executive Officer, heading the academic and administrative management of the university. UITM pledges to provide maximum opportunities to pursue professionally recognized programs of study in science, technology, industry, business, arts and humanities. University Technology Mara offers quality education at all levels of study, from foundation to postgraduate. The university has always been at the forefront in science and technology, as well as in management. It is a place where talent, skills and excellence are nurtured. UITM has a mission to empower the indigenous people through the provision of higher education in accordance with Article 153 of the Malaysian Federal Constitution and Act 173, University Technology Mara Act 1976. Duli Yang Maha Mulia, Sri Paduka Baginda Yang di-Pertuan Agong is the Chancellor of UITM by virtue of his status as the King, as provided for by the law. UITM has established 8 centers of excellence and 1 high COE to enhance the scholastic, creative and innovative capabilities of the university, as well as to facilitate and manage research and development. To complete the teaching and learning activities at UITM, the university has made available modern and contemporary facilities, such as the UITM Stadium, the house of UITM FC. With a capacity of 6,000, the stadium is the heart of soccer, and it has played host to an international match in 2009. UITM also has an Olympic-sized swimming pool for the use of students and staff. The pool is also open to public on certain days. Built in 1972, Perpustakaan Tun Abdul Razak, or the Pita Library, has grown by leaps and bounds, housing thousands of international titles for all programs of study. Students' participation in extracurricular activities is highly encouraged and supported by the university. These activities would not only equip students with soft skills, but also train them to be balanced and holistic individuals to meet global requirements. As the largest public university in Malaysia, University Technology Mara has produced thousands of alumni who are successful individuals in their disciplines. They are award winners, innovators, entrepreneurs, and leaders in both the government and private sectors. UITM honors its alumni by engaging them to establish smart partnerships resulting in strategic alliances. The alumni also gives back in areas such as academic improvements, charity work, and fundraising. University Technology Mara, Usaha Takwa Mulia.
Hey, you okay?
I was trying to find a strong Wi-Fi signal.
Well, look at all these things. They affect your Wi-Fi, you know.
What things?
The microwave oven, items with reflective or metallic surfaces, all these can cause interference. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
Come on! Why the Wi-Fi signal?
Scared you, didn't I?
Yeah.
No Wi-Fi signal, huh? Well, that's because you're in a Wi-Fi dead zone.
What?
Wi-Fi dead zone. In a big house like this, you're too far from your router, and walls can block your Wi-Fi coverage. Expand your coverage with Mesh Wi-Fi. Now, you have internet everywhere. No more dead zones.
not you. It's me. I just don't know how to relate to you.
It's not that hard, you know. It's like any other relationship. The better you know your dual band router, the better you can connect to your Wi-Fi. A dual band router lets you switch between two frequencies, whether you want speed or coverage. For gaming or streaming, 5 GHz will give you faster speed but within a shorter distance. But when you're further away from your router, switch to 2.4 GHz for wider coverage but slower speed. That's how you can enjoy drama-free connections anytime. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
For 60 years, University Technology Mara, or UITM, has been the place for acquiring knowledge and developing capabilities. From a training center to now a vast network of universities, UITM has campuses and faculties all over Malaysia. UITM allows for the pursuing of goals and earning a degree in any field of choice, with a mission to enhance the knowledge and expertise of Bumiputras in all fields of study, through professional programs, research work and community service, while upholding moral values and professional ethics. Nestled amidst the greenery and some of the most scenic areas in the country, each university campus is strategically located in places where their presence inevitably provides an economic boost to the local community. The Vice-Chancellor is the Chief Executive Officer, heading the academic and administrative management of the university. UITM pledges to provide maximum opportunities to pursue professionally recognized programs of study in science, technology, industry, business, arts and humanities. University Technology Mara offers quality education at all levels of study, from foundation to postgraduate. The university has always been at the forefront in science and technology, as well as in management. It is a place where talent, skills and excellence are nurtured. UITM has a mission to empower the indigenous people through the provision of higher education in accordance with Article 153 of the Malaysian Federal Constitution and Act 173, University Technology Mara Act 1976. Duli Yang Maha Mulia, Sri Paduka Baginda Yang di-Pertuan Agong is the Chancellor of UITM by virtue of his status as the King, as provided for by the law. UITM has established 8 centers of excellence and 1 high COE to enhance the scholastic, creative and innovative capabilities of the university, as well as to facilitate and manage research and development. To complete the teaching and learning activities at UITM, the university has made available modern and contemporary facilities, such as the UITM Stadium, the house of UITM FC. With a capacity of 6,000, the stadium is the heart of soccer, and it has played host to an international match in 2009. UITM also has an Olympic-sized swimming pool for the use of students and staff. The pool is also open to public on certain days. Built in 1972, Perpustakaan Tun Abdul Razak, or the Pita Library, has grown by leaps and bounds, housing thousands of international titles for all programs of study. Students' participation in extracurricular activities is highly encouraged and supported by the university. These activities would not only equip students with soft skills, but also train them to be balanced and holistic individuals to meet global requirements. As the largest public university in Malaysia, University Technology Mara has produced thousands of alumni, successful individuals in their disciplines. They are award winners, innovators, entrepreneurs, and leaders in both the government and private sectors. UITM honors its alumni by engaging them to establish smart partnerships resulting in strategic alliances. The alumni also gives back in areas such as academic improvements, charity work, and fundraising. University Technology Mara, Usaha Takwa Mulia.
Hey, you okay?
I was trying to find a strong Wi-Fi signal.
Well, look at all these things. They affect your Wi-Fi, you know.
What things?
The microwave oven, items with reflective or metallic surfaces, all these can cause interference. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
Come on! Why no Wi-Fi signal?
Scared you, didn't I?
Yeah.
No Wi-Fi signal, huh? Well, that's because you're in a Wi-Fi dead zone.
What?
Wi-Fi dead zone. In a big house like this, you're too far from your router, and walls can block your Wi-Fi coverage. Expand your coverage with Mesh Wi-Fi. Now, you have internet everywhere. No more dead zones.
It's not you. It's me. I just don't know how to relate to you.
It's not that hard, you know. It's like any other relationship. The better you know your dual band router, the better you can connect to your Wi-Fi. A dual band router lets you switch between two frequencies, whether you want speed or coverage. For gaming or streaming, 5 GHz will give you faster speed, but within a shorter distance. But when you're further away from your router, switch to 2.4 GHz for wider coverage, but slower speed. That's how you can enjoy drama-free connections anytime. For even better Wi-Fi experience anywhere in the house, I suggest using Mesh Wi-Fi.
For 60 years, University Technology Mara, or UITM, has been the place for acquiring knowledge and developing capabilities. From a training center to now a vast network of universities, UITM has campuses and faculties all over Malaysia. UITM allows for the pursuing of goals and earning a degree in any field of choice, with a mission to enhance the knowledge and expertise of Bumiputras in all fields of study, through professional programs, research work and community service, while upholding moral values and professional ethics. Nestled amidst the greenery and some of the most scenic areas in the country, each university campus is strategically located in places where their presence inevitably provides an economic boost to the local community. The Vice-Chancellor is the Chief Executive Officer, heading the academic and administrative management of the university. UITM pledges to provide maximum opportunities to pursue professionally recognized programs of study in science, technology, industry, business, arts and humanities. University Technology Mara offers quality education at all levels of study, from foundation to postgraduate. The university has always been at the forefront in science and technology, as well as in management. It is a place where talent, skills and excellence are nurtured. UITM has a mission to empower the indigenous people through the provision of higher education in accordance with Article 153 of the Malaysian Federal Constitution and Act 173, University Technology Mara Act 1976. Duli Yang Maha Mulia, Sri Paduka Baginda Yang di-Pertuan Agong is the Chancellor of UITM by virtue of his status as the King, as provided for by the law. UITM has established 8 centers of excellence and 1 high COE to enhance the scholastic, creative and innovative capabilities of the university, as well as to facilitate and manage research and development. To complete the teaching and learning activities at UITM, the university has made available modern and contemporary facilities, such as the UITM